Hello? Hello?
Good morning, sir. We are about to start the session. Good morning to all present here. The goal of aging research is not just to make people live longer, but to keep them healthy for longer, says Aubrey D. Gray.
We hope you all had a very wonderful session yesterday filled with insightful discussion and inspiring ideas. We are honored to extend a warm welcome to our respected dignitaries, esteemed speakers, faculty members, and dear students. We are truly glad to have you all here for another exciting day of learning and discussion.
Good morning. Check, check, check. The audience. If the audience have any discrepancies with the audio, please post a message. Am I audible through the stream?
Okay. Hello?
Check, check, check. Check. Good morning. Good morning. Good morning. Am I audible now? Good morning. Am I audible? We'll continue from the beginning. Or we'll just go. Check. Check. Good morning. SAAGECON 2026. Check. Good morning.
Check, check.
Sorry, if this here, working, it's working. I'll start. Good morning to one all present here. The goal of aging research is The goal of aging research is not just to make people live longer, but to keep them healthy for longer, says Aubrey de Grey.
We hope you all had a wonderful session yesterday filled with insightful discussions and inspiring ideas. We are honored to extend a warm welcome to our respected dignitaries, esteemed speakers, and faculty members and dear students. We are truly glad to have you all here for another exciting day of learning and discussion.
Within every cell lies a clock ticking softly through the rhythms of life. Our quest today is not to silence that clock, but to understand its language. So without any further ado, we'll kickstart the scientific discussions for the day.
Okay, let's get ready for a session that will change the way you think about aging. We are about to unpack the latest science on how we can actually measure aging process. Bringing the expertise to us is Dr. Murali Krishna sir with his talk on beyond filtration, the kidney as metabolic organ in aging and chronic disease. To invite the chairperson of this session, I call upon Rubasri.
A very good morning to everyone present here. I am Rubasri Gayatri, a final year postgraduate from the Department of Biochemistry. It is my great pleasure to warmly introduce the chairperson of this session, Dr. Indumati ma'am. Ma'am is currently working as a professor and head of the Department of Nephrology at Saveetha Institute of Medical and Technical Sciences, where she continues to make remarkable contribution to patient care, academics, and research. Regarding her academic journey, ma'am completed her MBBS and MD in General Medicine, followed by a Doctorate of Medicine in Nephrology from Madras Medical College. Ma'am has further enhanced her expertise with certification in nephropathology from the International Society of Nephrology and the Asian Network of Interventional Nephrology. Ma'am is a member of Advanced Clinical Trial Committee of the International Society of Nephrology. She has more than 30 publications in reputed national and international journals and also serve as a reviewer for several scientific journals. She is recognized as an international mentor for global kidney health. In recognition of her outstanding contribution, ma'am was awarded the Fellowship of the International Society of Nephrology in the year of 2024. Ma'am also serves as an executive member of Women in Nephrology India and as the scientific chair of Women in Nephrology Tamil Nadu chapter. We are truly honored to have such an eminent academician and clinician as our moderator for this session. With this, I now respectfully invite Dr. Indumati ma'am to take over the stage. Thank you.
Good morning, one and all present here. Thanks for the introduction. And a very good afternoon to Dr. Murali Krishna, Gangadharan Komala. A very warm welcome to you for this great session. In fact, Sir has completed his early qualification from India, MBBS from Chennai, Kilpauk Medical College, and MD from reputed institute PGA, Chandigarh. And then he went on to Australia to continue his education and career there. So he got his fellowship from Royal Australasian College of Physicians, and Dr. Komala did his PhD from Sydney University. His PhD topic is very interesting, it was SGLT2 inhibitors and DPP4 in diabetic nephropathy type 1 diabetes in rodents. So it was interesting, and this has also a role in what the topic is going to talk. And then he had more than 20 publications, the selected publications, and then written a lot of book chapters in nephrology. and currently he is working as a nephrologist in Napier Hospital, Australia. He is getting involved himself in many national guidelines on for example, in cancer chemotherapy in patients with kidney disease, and so on a lot. I can talk a lot of things about him, but for what of time we will go on to the topic. The topic today is very interesting and it is very different. Usually the nephrology topics will be like cardiometabolic or AKI or CKD, and today's topic is really interesting to me. I even went through that, and the topic today is beyond filtration, kidney as a metabolic organ in aging and CKD. Yes, we all know that kidney is a main excretory organ, excreting metabolic waste products and of course synthetic functions and all, like hormones, etc. But what as a central metabolic regulator, the kidney plays a major role. What do you mean by that central metabolic regulator is, not only the changes happens within the kidney, it has an important role in maintaining the metabolic status of the whole system. So that is how it plays an important role, and aging happens, like a lot of changes happens within the kidney, and including the GFR declines with the aging. But what happens to the physiological aging and the aging in patients with CKD? So there is an accelerated aging happens in CKD, and how to prevent that, and thereby the cellular senescence can be reduced. So the recent concepts starts from cellular level, mitochondrial dysfunction, clotho deficiency. Clotho is very essential as an anti-aging factor. So all these things are coming into play for coming into role as a kidney. So kidney plays a major role, which is usually a silent organ, but it is a major metabolic endocrine, metabolic organ. I request Dr. Murali Krishna to go ahead with it. Thank you.
A lot to unpack here, but we'll just focus on the main concepts. So beyond filtration, the kidney is a metabolic organ in aging and chronic disease. What happens to kidney in aging and what happens in kidney disease? Let's unpack them slowly. So basically, I'll just list out the functions of the kidney. The first and foremost, the most important function of the kidney is filtration, removal of urea and toxic products of metabolism, maintaining fluid balance. So if you want to say two things which are extremely important, which is filtration, removal of toxins, and removal of maintenance of the fluid balance. Then the next important thing is maintenance of acid-base balance. We maintain a pH between 7.34 and 7.44. And that's a very tight, narrow balance, and the kidney plays an important role along with other buffers in maintaining the acid-base balance. It has important endocrine functions, which includes erythropoietin secretion and activation of vitamin D for bone metabolism. It has an important role in glucose homeostasis and gluconeogenesis. Renin secretion is important in blood pressure regulation and also in kidney health. Then we also talk a little bit about clotho production in phosphate balance and in calcitriol formation as well. So what are the aging associated changes? Let's focus for the first few minutes on the aging associated changes in the normal kidney. What happens to the kidney as we age? So there is increasing accumulated oxidative stress in the kidney because as the kidney keeps processing all the toxins, it is a highly metabolic organ, and there is an oxidative stress which builds up. There is increased production of reactive oxygen species, which in young kidney is able to get rid of or neutralize very easily. Now there are sirtuins which are critical antioxidant molecules which are present, and we have found that they do reduce with age. And these sirtuins are important for countering reactive oxygen species and in enhancing autophagy. Autophagy is the process where the cell reaches the end of its life and it's recycled and it's destroyed appropriately so that it doesn't stay around and cause problems. Now we know that absence of SIRT1 or sirtuin-1 is known to increase apoptosis. Apoptosis is the excessive cell death and aging in experimental animal models. Now, if for any reason we are not able to neutralize the reactive oxygen species, the reactive oxygen species are required, but if they build up and there is excessive amount of reactive oxygen species which cannot be removed, they lead to DNA damage, and more DNA damage leads to more aging-related problems. Now, what is the role of klotho? Klotho is a molecule which is mostly made in the kidney. It is a cofactor of FGF23. So, klotho and FGF23 work together. The FGF23 is fibroblast growth factor 23. Now, these are important in phosphate excretion. So, the kidney, one thing to remember is the kidney is the one and only major route for phosphate elimination. So, if you develop kidney disease, the first thing that happens is the phosphate starts building up. So because the kidneys are not able to eliminate this, and this leads to more FGF23 production, and then there is downstream PTH production, parathyroid hormone production, and that starts a cycle of abnormal calcium and phosphate metabolism. So it is important in phosphate excretion. It inhibits calcitriol formation and attenuates PTH release. So it kind of tends to quieten the active processes that will happen in the body. It is also important for inhibiting WNT signaling. Now, what is WNT signaling? WNT signaling pathway is a profibrotic pathway, and by controlling this profibrotic pathway, the klotho is able to reduce the aging process. It suppresses downstream signaling pathway for insulin-like growth factor. Now, insulin-like growth factor, again, we know it promotes growth and promotes excessive growth and more fibrosis. And it also inhibits TGF-beta signaling. If you know all the fibrotic pathways, they all culminate in TGF-beta. And transforming growth factor beta is one of the important molecules which promotes fibrosis, and it's a downstream. It is a culmination of a downstream pathway for a number of pathways. So hence, klotho is an anti-aging molecule, and we know that klotho levels are negatively correlated with aging. And there is also experimental evidence to show that klotho deficient mice are associated with hypercalcemia, hyperphosphatemia, and when you have very high calcium and very high phosphate, which happens in kidney disease, when you give calcium supplementation for patients with kidney disease, you have a high calcium phosphate product, and this deposits in the vessels and causes vascular calcification. This is one of the reasons for vascular calcification, coronary artery disease in patients with kidney disease. Now, Dr. Ndimuthi mentioned briefly about cellular senescence, and this is the process where the cells are dying. Now, these cells are able to replicate, especially the epithelial cells and the endothelial cells are able to replicate and change over, and fresh layer comes regularly. But repeated cellular division does cause telomere attrition, which results in senescence. So every time they replicate, after a particular number of replications, there is telomere attrition, and the cells can't divide anymore. Now, what leads on to this is more oxidative damage. There is increased mitochondrial stress. Does cause telomere attrition stress. Then there is inflammatory signaling, which can independently cause senescence. Now, one of the things to remember is the kidneys are very, very rich in mitochondria, especially the proximal convoluted tubule. It's a very highly metabolic organ. And it also, there is a lot of aerobic oxidation which goes on in the kidney, in the proximal convoluted tubule. Now, what are the markers of senescence? There are molecules like P16 and senescence-associated beta-galactosidase. Now, these have all been noted to increase in aging organs, including the kidney tubular cells as well. Now, one thing to remember is if you look at the glomerular cells as well as the tubular cells form around 90% of the kidney. So if you take a cross-section or a biopsy, if you look at the biopsy, you'll find that the 90% of the area is covered by the tubules, and only 10% is covered by glomeruli. So the tubular epithelial cells are of prime importance compared to the glomerular cell in aging, as markers are mostly expressed in the tubular cells. Now there are other processes in aging kidney. As we all get older, apart from the fact that the kidney is getting older, we also have other hits on the kidney. And this includes things like chronic inflammation related to diabetes, due to hypertension, and we take medication for all of this. And all these medications have to be excreted through the kidney. So they all have a cumulative effect on the kidney. Now, what are the structural changes? So there are structural changes, there are physiological changes. So the structural changes, the kidney volume tends to come down. So if you take look at an ultrasound of a young person as well as a kidney of a younger person as well as an older person, you'll find that the cortex or the outer layer of the kidney decreases in size. So there is a decrease in the kidney cortical volume and an increase in the medulla. So the medulla is the inner portion of the kidney, it tends to increase. And there is, if you drill down and have a look at the biopsy of an old kidney, you'll find that there is glomerular sclerosis. It's nothing but hardening of the glomerular line, and there is subsequent nephron. So when the glomerular head dies, the tubules which are attached to that also die. And then there is tubular atrophy. So as we get older, we start losing a lot of our nephrons. So the capsule of the kidney also starts developing fibrosis, and the blood vessels inside the kidney start developing arteriosclerosis. That's probably because of hypertension, mostly hypertension, and also related to diabetes as well. So what we're trying to form, the story we're trying to tell is that there is an aging kidney, and there are other hits which are coming onto the kidney as well, like in any other organ, like diabetes, hypertension, high cholesterol, obesity. All these things will culminate in the aging process. So what we should try and do is we should try to reduce the risk factor. Aging we can't change, but we can try and reduce the other risk factors that affect the kidney or other organs. Now, what are the functional changes? So we have the structural changes. What are the functional changes that we see in the kidney? Now, your GFR, or the glomerular filtration rate, it increases up to the age of 30, right? It can go right up to 140 mils per minute, which is really good. But then afterwards, subsequently, there is a decline of 8 mils per minute for every decade. So let's say you reach the age of 80. So you add another 50 years to your 30 years of age. And 50 into 10 is 50 into 5 decades, 5 into 10, 50 mils. So you lose probably another 50 mils just by the process of aging. So your GFR might drop down to 90 or 70 or sometimes 60, depending on how many risk factors you have. So there is, as you get older, there is a heightened sensitivity to volume deficit. So as we get older, if you become a bit dehydrated, you have a bit of diarrhea or vomiting, your volume deplete, you take a longer time to recover. And it's also, there is also heightened vulnerability to drug toxicity. Unfortunately, as you get older, we are not taking lesser drugs, we are taking more drugs. We are taking more medication. We are taking medications for blood pressure, we are taking medications for diabetes, we are taking medications for cholesterol. So we are taking a lot of medication. So there is a propensity for drug toxicity as you get older. And there is also heightened vulnerability to electrolyte disturbances, which we'll come to later again. Most importantly, hyponatremia and hyperkalemia. You would see a lot of old patients whose sodium levels are just below normal. And we can try doing a number of things, but we can't correct it. So there is these electrolyte disturbances which we find uniquely in the elderly. And there are body composition changes. As we get older, the total body water comes down and there is increase in fat, and this happens in the kidney as well. So what is the role of mitochondria? The mitochondria is very important for the kidney. So if you look at diabetes, many of the abnormal pathways are mitochondria related. So the kidney has abundant mitochondria due to vigorous metabolism. So mitophagy is a process of removing damaged or old mitochondria. And if you start accumulating mitochondria, it is a sign of poor mitophagy and it's a sign of aging. And the active inflammation mediated through excessive mitochondria also accelerates aging. So as you get older, you have less mitophagy, you have more of the old mitochondria sitting around, there is more inflammation, and that accelerates the aging process. So decline in mitochondrial function is also associated with reduced ATP. So you don't have the energy in the cell to function appropriately. So let's dwell now that we looked at the different components of the aging and the effect on the kidney, we can dwell on the metabolic and the endocrine functions of the kidney. So the kidney glucose is very important. Now we know about SGLT2 inhibitors. It's very widespread use of SGLT2 inhibitors in the management of diabetes because it works through the kidney. And we also have good evidence now that it is a very good cardiovascular drug as well as a renal protective drug. So it's got in separate indications for heart failure and also for kidney disease. So what is the role of what are the things that happen with glucose in the kidney? Now, next thing is erythropoietin secretion and anemia response. So, why is the kidney important in anemia? Why do patients with dialysis or patients with kidney disease have anemia? And why do patients with kidney disease have bone disease? What is the role of the kidney in activation of vitamin D and bone metabolism? Now, what is the role of the kidney in acid-base balance? And how does the renin-angiotensin system change as we get older? And what is the connection between kidney and cardiovascular disease? We'll briefly touch upon all this. So first is the glucose metabolism in kidney in health. So the kidney is a major consumer of energy. So it consumes nearly 400 kilocalories per kilogram per day. It's probably the second or third most energy consuming organ in the body. It participates in glucose filtration and reabsorption of almost 99.9% of the filtered glucose. And the process, glycolysis is a process of conversion of glucose to pyruvate, which is used in the tricarboxylic acid cycle to produce adenosine triphosphate or ATP. ATP is your cellular currency, energy currency. Now, the other important thing we need to know is gluconeogenesis. Now, gluconeogenesis, we always think of the liver. As the liver stores glycogen and it releases glucose when required. The metabolic pathway in which glucose is produced from non-hexose precursors such as lactate, pyruvate, glycerol, and glycogenic amino acids. So it converts all of this into glucose. Now, it's interesting to note that kidneys generate nearly 28% of the body glucose by gluconeogenesis in the normal state. And if you are under stress, it can even do 40 to 50% in stress conditions. So what are the glucose metabolic changes in chronic kidney disease? So the major energy production in the kidney is through fatty acid oxidation in normal circumstances. Right? However, in hypoxic state and inflammation, there is a switch to glycolysis. So what are the hypoxic states? It could be either somebody having an acute kidney injury because of drugs, could be because of an acute kidney injury because of volume deficit. It could be a kidney injury due to cardiac failure. It could be due to rhabdomyolysis. It could be a hypoxic state is when there is not enough blood supply or where there is a state where there is not enough oxygen delivery to the tubular cells. And then there is inflammation, which again, hypoxia itself leads to inflammation. Now, when you have hypoxia inflammation as a metabolic survival mechanism, there is a switch to glycolysis. It starts making lots of glucose. Now, the metabolic switch is to help in survival. Now, the distal tubular cells are more likely to survive in a hypoxic state compared to the proximal convoluted tubule, because the proximal convoluted tubule depends more on the oxygen-based pathways, so in ATP generation. So they're not able to survive for long in an anaerobic environment. Aerobic pathways are more prominent because they have a lot of mitochondria. So the metabolic switch is a survival mechanism, but the metabolic switch is associated with loss of the mitochondrial gene expression and worsened kidney prognosis. It's a survival for a short term, but in the long term, it causes worsened kidney prognosis. Now that's a hallmark of chronic kidney disease. So again, this is a cartoon showing what happens in patients with CKD, glucose metabolism in CKD. You can see that as the patient progressively has progressive CKD, the gluconeogenesis and the fatty acid oxidation comes down, and we can find that most of the metabolic process that is happening in the kidney is glycolysis. And you can see all the markers of a gluconeogenesis seen in a healthy kidney like PCK1 and FBB1, and glucose 6-phosphate is all reduced. And we have reduced lactate clearance. We have increase in intracellular lipid accumulation because obviously we are not using the fatty acids. There is reduced proton clearance, so there is H plus accumulation. And the glucose in serum comes down, and that's also because of the fact that the kidney, in a chronic kidney disease, there is reduced insulin degradation, there is more insulin floating around. And there is, because of the retention of the protons, you have more acidosis. Now, is chronic kidney disease a storage disease? Now, we saw that there is lipid accumulation, there is glucose not being utilized, well, there is glycogen accumulation. So, loss of fatty acid oxidation is associated with accumulation of lipid droplets. Now, there is a potential for there is a toxic potential, but there is clearly, currently there is no clear-cut evidence for the toxicity. Glycogen accumulates in the thick ascending limb in the distal tubule. However, there is again no concrete evidence to suggest toxicity. However, we know that SGLT2 inhibitors have been shown to induce renal improvement in patients with glycogen storage disorders. So maybe it prevents glucose entry into the tubular cells and helps in glucose excretion, thereby reducing the load. There is poor lactate clearance and possibly increased fibrosis as well. Is everybody able to hear everything? Is there any issues?
Yes, sir. Yes, sir.
Okay, I'll continue that. Thanks. So now, is there a therapeutic role for SGLT2 inhibitors? Now, SGLT2 inhibitors as they started with diabetes, then they had influence in improving heart failure, then they are now indicated for kidney disease. So, is there a therapeutic role for SGLT2 inhibitors in beyond this and beyond standard diabetes and in other conditions? The main mechanism of action is the prevention of proximal tubular glucose reabsorption, prevents entry of glucose into the tubular cells, and it prevents the metabolic switch. And it also stimulates gluconeogenesis by inducing PepCK and G6Pase. So these are some enzymes that are present. And there is also some, in one of the conferences, they mentioned that yes, SGLT2 inhibitors should probably be mixed with water because it's in the drinking water because it's good for everybody. But we are not there yet, and SGLT2 inhibitors do have some adverse effects as well. But generally, by and large, if there is an option for using SGLT2 inhibitors in patients with diabetes or kidney disease, or where there's a lot of proteinuria, then we should try and employ that. Now, we finished glucose. Now we'll look at the role of the kidney in anemia. So what is erythropoietin? Erythropoietin is the hormone which is produced by the peritubular fibroblast in the renal cortex. So EPO mRNA is also found in small amounts in other organs and may be produced in small amounts, but not as much as the kidney. Now, we know that EPO production increases with age primarily because the bone marrow becomes less sensitive to stimulation. The way the EPO works is, so if there is hypoxia or low hemoglobin detected by the peritubular fibroblast in the renal cortex, it secretes erythropoietin. This erythropoietin goes to the bone marrow and stimulates erythropoiesis or production of more red cells. Now that marrow becomes, as we get older, becomes less sensitive to the EPO. Hence the EPO levels tends to increase because the kidney makes more EPO. But if you look at a younger person and an older person, the response of the EPO from the kidney or the EPO secretion by the kidney is lower in an anemic elderly compared to the anemic young, suggested that the kidney also doesn't make enough EPO that is required for the degree of anemia. So this is one of the things that happens with aging. So you'll find some, as we get older, you're more prone for anemia, and there's a number of reasons that for that, including the poor bone marrow response, as well as the reduced blunted EPO response from the kidney. And again, EPO production declines. So when kidney disease happens, obviously this is much more pronounced, And you'll find that most patients in CKD 4 or 5, or when they are on dialysis, they need erythropoietin supplementation. Previously, 30 years back, we used to give them blood transfusions, leading to iron overload. We don't do that now. We give them EPO. And that is to supplement the EPO production by the kidney, which the kidney is not able to make. Now, anemia and CKD, you should also remember, is also due to reduced red cell lifespan. There is a malnutrition that is associated with chronic kidney disease, and there is also the action of hepcidin. Hepcidin is a molecule which reduces iron absorption in patients with kidney disease, unfortunately. So now coming to vitamin D and bone metabolism. So why is the kidney so important, vitamin D and bone metabolism? So the skin has 7-dehydrocholesterol. On sun exposure or UV light, you get pre-vitamin D3, and that is either derived from the diet or from the sun exposure, and it is converted to 25-hydroxy vitamin D in the liver, and it's the second hydroxylation of the 125 dihydroxy vitamin D is activated in the kidney. Now, when the kidney function goes down, obviously there is not enough of the 125 dihydroxy vitamin D, and because of that, the bone and calcium metabolism gets affected. Now, some extrarenal tissues can also make 125 dihydroxy vitamin D, like the pancreas, prostate, colon, and breast, but not as much. And is there a role for just 25 hydroxy vitamin D in metabolism? Yes, there is some role, but the bone metabolism primarily depends on 125 dihydroxy vitamin D. So there is altered vitamin D metabolism with aging, and then there is a role for the aging kidney in the abnormal bone metabolism. So these are the effects of age on vitamin D and calcium metabolism. So first, there is reduced calcium absorption from the gut, and there is an intestinal resistance to calcium absorption to circulating 125 dihydroxy vitamin D. So if you have more vitamin D, active vitamin D, the bowels are a bit resistant to absorb the calcium. There is reduced vitamin D receptor. So if you have vitamin D, there is not many receptors ready to accept the vitamin D and act and have those metabolic changes. There is reduced renal production of 125 hydroxy vitamin D with the aging kidney. Again, because we are losing some nephrons, and some of the as we lose nephrons and the kidney reduces in size, we are not able to make the same amount of active vitamin D like a normal young person. There is decreased skin production of vitamin D, and there is also substrate deficiency of vitamin D. So we are not getting enough vitamin D in our diet as well. So it's a culmination of a number of factors which leads to abnormal vitamin D metabolism. Hence, as we get older, we have problems like osteoporosis, kidney disease related bone disease. Now that is more of a problem with patients with kidney disease. If we just have pure aging, it's most likely related to be vitamin D deficiency and osteoporosis. Now we'll touch a little bit on acid-base balance. Now, as part of our diet, we consume a lot of protein, and I consume a lot of animal protein and vegetable protein. So the metabolism of animal and vegetable protein leads to a lot of amino acids being generated, mainly cysteine, methionine, lysine, and arginine. Now what these amino acids, the metabolism of these amino acids leads to is production of protons or H plus ions. Now fruits and vegetables in turn are able to neutralize this because we have citrate, and citrate metabolism leads to bicarbonate, and there is the bicarbonate neutralizes the protons. However, the total amount of bicarbonate is not the same as the amount of protons, and there is a net difference. So there is a net endogenous acid production which is roughly equal to 1 to 2 milliequivalents per kilogram of body weight per day. So how do we neutralize this acid? Because if we have a lot of acid buildup, we can't maintain our pH between 7.34 and 7.44. And if you have chronic acidosis, then you have other metabolic downstream effects. So the acid-base balance is maintained by buffers. Buffers are basically what they are. They kind of take the shock of something, like you have a lot of protons coming into the system, they absorb that and prevent the pH from shifting too much. The tissue buffers for acid are muscle and bone are very good buffers. Now there are other buffers like phosphate in the blood, in the serum, and they are also good buffers. And but however, the majority of the buffering is done by the kidneys. So the kidneys play a major role in buffering acid. So what they do is they reabsorb the bicarbonate from the tubules. You know, if they look at the how the ions are excreted, we have a lot of pathways, and at different sections of the tubule, the bicarbonate is reabsorbed. In the proximal convoluted tubule, we have the hydrogen and sodium exchange, which is ATPase driven. Obviously, it takes energy, and it gets rid of the proton and gets sodium into the system. It also has, the proximal convoluted tubule also has the sodium potassium ATPase. So you lose 2 potassium and take 3 sodium back. So you have a net sodium absorption. And you also, because of a positive charge, you take a negative charge, which is the bicarbonate. Now these are some ways in which the net balance or the bicarbonate is reabsorbed. But the other most important thing that especially happens in the distal convoluted tubule is the production of ammonia and excretion of ammonium. Now ammonium is able to capture a lot of the protons, and the production of ammonia and excretion of ammonium and titratable acid results in further reabsorption of bicarbonate. So one thing to remember is if you lose 1 proton, you gain 1 bicarbonate. So that's how we lose. That's how we maintain the balance. So the ammonia generation is also affected as we get older, and hence we are not able to maintain the ability to maintain a tight acid-base balance. We lose as we get older. So there are phosphate and other buffers, as I mentioned earlier, which are also involved in reducing the acid burden. So in chronic kidney disease, there is a reduced ammonogenesis, there is poor acid buffering capacity, there is increased systemic acidosis. Because of this, there is increased systemic acidosis. So this systemic acidosis, where do all this acid gets buffered? It gets buffered by the bone, and because of that, it tends to chelate calcium out. So progressive kidney dysfunction with systemic acidosis, there is evidence, but what does acidosis do to the kidney? So we also have some evidence to say that in an acidotic environment, the kidney disease progresses further. So progressive kidney dysfunction, systemic acidosis, there is evidence to suggest that preservation of kidney function with maintenance of acid-base balance through pharmacological measures in CKD. However, we need more studies to confirm this. What it means is if somebody with chronic kidney disease, because they're not able to maintain acid-base balance, they're chronically mildly acidotic, we give them sodium bicarbonate, by which we try to bring the pH into a normal range. Now, with that, there is some evidence that we can actually slow down the progression of kidney disease as well. So, for all other enzymatic process and metabolic processes, we want to maintain a good acid-base balance, and also for prevention of progression of kidney disease, we want to maintain the acid-base balance. So what are the complications of chronic metabolic acidosis? So we have bone loss, as I mentioned earlier. We have osteoporosis, osteopenia, and we also have muscle loss as well, the sarcopenia, because they are trying to buffer the acid and they are also struggling in the process, and they lose that content. There is mineral loss from the bone matrix. There is increased osteoclastic activity, which means there is more bone breakdown. There is reduced osteoblastic activity, so there is less bone building. And there is muscle loss and reduced muscle strength. There is connective tissue loss, which the connective tissue is the tissue that holds all the bone cells together. And there is fibromyalgia. There is increased uric acid, because the kidneys are again essential in eliminating uric acid, and then you have accumulation of uric acid, and then people who have a propensity for gout develop gout as well. And overall, and there is kidney function decline, and there is more tubular interstitial damage with acidosis, as we mentioned earlier, that kidney disease can progress in an acid milieu. Now we'll briefly talk about kidney and renin-angiotensin system in aging. This is a brief, small cartoon which everyone knows. We have angiotensinogen produced by the liver, and renin from the kidney acts on it, converts it to angiotensin 1. The angiotensin converting enzyme is present in the lungs. It converts it to angiotensin 2. It acts in the adrenals to promote aldosterone formation, which acts on the heart and the blood vessels, and it causes vasoconstriction and increased blood pressure. There is action on the kidney, which leads to sodium and water retention, which again causes increased blood pressure. So what is the role of aging on renin-angiotensin system? The renin excretion is inhibited with aging. However, and also the aldosterone secretion with the adrenal gland is also blunted. However, local angiotensin 2 production is increased. Now, what does angiotensin do? It tends to cause fibrosis, glomerular sclerosis, and that is one of the reasons why the kidneys are slowly long-term exposure to angiotensin 2. The tubular sodium and potassium handling is also blunted. So, elderly populations on a salt-restricted diet may have reduced ability to conserve sodium and they develop hyponatremia. This is one of the reasons why many older patients may have mild hyponatremia. And they're also more prone for hyperkalemia as well because they have the reduced ability to get rid of the potassium. And they're also susceptible to hypovolemia because if you don't retain sodium, you tend to lose fluid. And because of that, you can become more hypovolemic. There are other factors apart from aging which can affect renin levels, let's remember, which is genetics. So there are high renin levels in first degree relatives with hypertension and reduced sodium excreting ability. And again, in patients of African origin, they have the same issue because they have inability to excrete a sodium load and they have higher incidence of hypertension as well. So what is the effect of the role of the renin-angiotensin system on aging? So there are several structural changes that are affected by angiotensin 2. There is some experimental evidence to show that enalapril has been shown to decrease aging-related changes in mice. What are the mechanisms? It could be because of reduced oxidative stress, improved vasodilation, reduced inflammation. So hence, right now in the context of hypertension, yes, they are very good medications. In the context of proteinuria, they're very good medications. In the context of cardiovascular disease, very good medication. But when we want to use them as an anti-aging agent, not entirely sure at this point in time, and we wouldn't want to try that. Renin-angiotensin activation can also promote progression of other conditions seen in older patients, like if you have obesity, diabetes, hypertension. The renin-angiotensin system is very active in patients with these conditions. So if you have any of these risk factors, inhibiting the renin-angiotensin system is very important. But the interaction between the renin-angiotensin system, different metabolic pathways, and aging is quite complex. Now, briefly, the last topic. I know we are close to time. We'll talk about kidney and cardiovascular disease. This is just a small graph. It shows that this is a young person who is in the 20s or early 30s, and this is their annual mortality. You can see that the mortality of someone with chronic kidney disease is extremely high. It is similar to the mortality of someone who's in the 70s without any form of from the general population. So when you have kidney disease in your 20s or 30s, your mortality is as high as someone in the 70s. So, and you have a very high mortality rate as well. So kidney disease is associated with increased cardiovascular risk. Now, there are different reasons for that. Looking at this cartoon, you'll find that hypertension is increased in patients with kidney disease. There is increased inflammation. There is increased endothelial vascular calcification. And then there is a lot of uremic toxins floating around which are not good for the heart, and coagulation abnormalities as well. And on top of it, you had diabetes and obesity and other problems. It increases your cardiovascular risk. So the risk factors for cardiovascular disease and chronic kidney disease, you have traditional risk factors like hypertension, dyslipidemia, smoking, hyperglycemia or high sugars. The non-traditional risk factors are vascular calcification, inflammation, and increased proteinuria. Somebody with the more the proteinuria, the higher your cardiovascular risk. To summarize, the aging kidney is subject to a reduced ability to maintain homeostasis. Homeostasis is the ability to maintain everything in balance despite shocks to the system. Several physiological mechanisms become progressively less efficient. There is a structural and functional decline. Numerous cellular mechanisms, including mitochondrial activity and reactive oxygen species generation, is altered. The aging body is also subject to other metabolic and hemodynamic stresses, including diabetes, hypertension, and hyperlipidemia. So the culmination of aging and chronic metabolic challenges results in declining kidney function. The declining kidney function in turn affects cardiovascular morbidity. So the key is prevention or better control of metabolic derangements to help sustain kidney function and prolong the effective filtration, endocrine, and metabolic functions of the kidney. So we are right now in a better phase. We have SGLT2 inhibitors, we have GLP-1 agonists, we have non-steroidal aldosterone antagonists. So we are in a phase where we are able to prolong the life of the kidney and generally an individual because of newer medications. So with that, I'll conclude and I'll take questions.
What a fantastic and engaging session that was, sir. Thank you for sharing your expertise on the subject. And as sir said, the session is now open for discussion. If anyone has doubts, you can clear it now. Anyone have any doubts? Any doubts? Okay, with that, now I call upon Dr. No, ma'am, no doubts.
So we all had a wonderful lecture, Dr. Murali Komala. The thing is, he very diligently explained the very basics of physiological functions of the kidney other than excretory function, and how it happens physiologically, then with aging and in CKD. It was explained in detail, and as our geriatric population is increasing, nearly more than 1/3 of the population is geriatric, and it has to be lived with the quality of life, and hence this topic was very, very appropriate. And I thank once again Dr. Murali Komala to have the wonderful lecture from you, sir. Thank you.
Thank you.
Thank
Thanks
you,
a
ma'am.
lot. Do you want me to disconnect now?
Hello, sir. Thank you for your very nice presentation. Regarding SGLT2 inhibitors and GLP, you said, yeah, it is very approved for renal failure. I am very happy with that. But in terms of aging, they tend to cause sarcopenia. That is what the issue is going on. So how we are going to deal with both the aging and the CKD? Can you elaborate on that? Thank you.
That's a very good question. I think the sarcopenia is more of an issue with GLP-1 agonists, and maybe less of an issue with SGLT2 inhibitors, because the SGLT2 inhibitors will cause some weight loss. Some of the weight loss initially is due to volume deficit because you tend to lose a lot of fluid, but then subsequently it's calorie loss. But SGLT2 inhibitors do not cause that much of weight loss as an issue. But nowadays, obviously, we know people are going after the GLP-1 agonist just purely for weight loss. It is like it is a popular medication now. Yes, sarcopenia is very. So the advice would be that sarcopenia is not good for aging. Sarcopenia is associated with frailty, increased falls risk, and other problems, and also poor bone health. So the advice would be to make sure that even though you're on GLP-1 agonist, you should definitely have weight training and maintain your fitness, and make sure you don't lose your balance and other things. So if you are losing excessive weight and you're becoming more sarcopenic, then it's time to come off. And especially this has to be indicated for people who are obese and who are overweight and who have a metabolic issue. And once you reach a particular level, you are at a particular dose, then maybe dose escalation should not be, you should not go like 2.55, 10, 7.5. So that has to be monitored. And the other thing with GLP agonists also is that we should also remember that in patients with diabetes, if you have on GLP-1 agonists, you should probably monitor for retinopathy more closely as well, because there is a signal that there is increasing retinopathy because the significant improvement in the diabetes, the ocular pressure changes dramatically. So there is a risk for retinal hemorrhage and worsening retinopathy. So there are certain signals, but overall, if you look at the trial evidence, the GLP-1 agonists are very good. But again, as you mentioned, we need to have 10-year data, 15-year data, which we don't have. So
Thank you so much.
Hi, sir. Good morning, sir. So it was a nice presentation, sir. I have a small question, sir. So it may be basics. So I would like to know whether this antagonist, which is we are trying to implement, whether this will be very helpful in staging of kidney, the CKD, sir. So I just want to know that because we had done a study like those who have the CKD, based on the staging and the impact of cardiovascular diseases, there is a high risk of mortality. So whether this antagonist will be beneficial in any stages of CKD, sir. So I just have a doubt of that.
the question was basically, I didn't get the audio was not entirely clear. So you said there is increased mortality in and staging in the kidney, but what was the
Sir, those who are in the stage 4 and stage 5 of CKD, so obviously if they have the comorbidity status with the cardiovascular disorders, there is a high risk of mortality status, sir. So my basic question is like whether these type of antagonists will be highly beneficial in any stages of the CKDs, or it might be like stage 1 and stage 2. Is it like that? So I just want to know, I was curious about that. If it is beneficial in the later stages of CKD also, it will be highly protective for the CKD patients. So that's why.
the CKD stage 3 onwards is when I think the mortality and morbidity increases. The CKD 1 and 2 maybe not that much. I mean, the CKD 1 and 2 is because they either have structural or changes or some albuminuria. So yeah, so I don't know if that answered the question.
Okay, sir. Thank you so much, sir.
Any more doubts? Any more doubts now? Okay, with that, no more doubts. We are concluding the session. Now I call upon Dr. Ananthi ma'am and Dr. Guripavan sir to felicitate the speaker and chairperson.
Yes, sir. Thank you for the wonderful and informative session, sir. Thank you. Okay, thank you for the wonderful and informative session, sir.
For this session, Dr. V.M. Vinodhi Ma'am, Professor and Head of the Department of Biochemistry, SRM Medical College, Hospital and Research Center. Ma'am completed her MBBS and MD in Biochemistry from Madras Medical College and has been serving the field of medical education and clinical biochemistry with remarkable dedication for more than 20 years. Her areas of expertise include clinical biochemistry and lipidology with strong research interested in cardiovascular risk markers, metabolic syndrome, laboratory quality management, and endocrine biochemistry. Ma'am has guided numerous postgraduate and PhD scholars and has published more than 50 research articles in reputed national and international journals. She has received several prestigious awards, including first prize at national and international conferences. She served as a chairperson, organizing chairperson, guest speaker, and judge in numerous scientific sessions. She is a life member of the Association of Medical Biochemists of India, serves on the Institutional Ethical Committee, and has played a significant role in curriculum development and laboratory accreditation process. Her dedication to teaching, research, and academic leadership truly inspires all of us, ma'am. We are extremely fortunate to have such a distinguished academician and researchers among us today, ma'am. On behalf of everyone present here, I extend a warm welcome to you, ma'am. With great respect, I now invite Dr. V.M. Vinodhi ma'am to the stage. Thank you.
A very good morning to everyone present here. It's indeed an honor and a privilege to be here at Saveetha Medical College for this conference on anti-aging. And I would like to start by reminding myself and all of us of a very favorite quote of mine. Could be some changes in that. Let's not be afraid or scared to get old, because getting old is a privilege which has been denied to many of us in this world. And with that, I go on to a brief introduction of Manju ma'am. Ma'am had her MBBS training from the prestigious TD Medical College, Government Medical College, Alappuzha, Kerala University. MD Biochemistry training from Arupadavidu Medical College, Puducherry, Vinayaga Missions. Madam currently serves as the head of biochemistry at AVMC, thus making her alma mater proud of her. And her passion towards medical teaching is indicated by her training in ACME, the advanced course in medical education, as well as the prestigious FAMER offered by at PSG IMA Coimbatore, both of which are very demanding curricular programs. And she has also been the head of clinical laboratory at AVMC. And regarding Madam's research interests, Madam has an astounding number of 26 research publications with having guided 4 ICMR STS and also having obtained research grants from the government of Puducherry. So we were all very honored to have Madam's presentation here. Looking forward to your presentation, Madam. Thank you so much.
I want this to be, this is the change. This is the right. Want, I'll use this. So, good morning all. So at the outset, let me first thank Vinodini ma'am for giving me such a great introduction. She's a great friend of mine. It's an honor, ma'am, you introducing me. At the offset first, let me first thank the organizers, especially Anandi ma'am and the Professor Dr. Surya Priya ma'am for giving me an opportunity to speak before in this August gathering, academic gathering. So, ma'am has already introduced me. So the talk that Surya specifically gave me was on optimizing aging through nutrition, interventions for cognitive and physical vitality. So before I start the talk, let's go through some pics. Yeah. All of us saw the pics. I think when you go through these pics, see everybody's faces are very happy. Okay, yeah, I can see the happiness. So what does this? We can relate all these pics to our real-time things. Either these pics remind us of our own parents, or in-laws, or somebody while we go for a walking in the park, a group that we see, or we visit in old age homes. We cannot neglect that also. Old age homes or any other homes when we visit. These are all the pictures that the regular things that come to our mind. But whatever it is, when you go through these pictures, what you see is all of them are happy and all of them are aged. Though we don't like to call ourselves aging, like what Madam started with. It's a privilege to get aged. There are a lot of people who are deprived. They don't get to aging also. It's not nothing that aging is not a disease. Let me start with that. So with this thing, so if they are happy, they are healthy. Okay. So with these pictures in the background, let me start on my topic. So when this topic comes aging, from yesterday you all have been hearing about the various definitions of aging and all. So I would like to replace this word, not I would prefer, because even World Health Organization prefers calling instead of using the word aging, it would be rather called as healthy aging, because aging is something which is inevitable. So let us age in a healthy manner. So we'll be using the word healthy aging. And whenever we speak of the word aging, lifespan comes to us. Let it be chronological age or the biological age, lifespan comes. And it's not living, the lifespan doesn't mean that living for how many years. So living with health. So the term called as lifespan is also now synonymously being replaced by the term health span. With this, I would like to tell that World Health Organization has declared this decade, that is 2021 to 2030, as a decade of healthy aging. This itself shows the importance of this topic that Saveetha Medical College and Biochemistry Department has selected for this as a theme of this conference itself. So this is the decade of healthy aging, and this initiative is nothing but a global initiative taken by WHO to shift the focus from just not treating. If you become old age, just treat their diseases. That is not healthy aging. They are telling that we need to not only treat the illness of the old age people, but we need to support the older people to live well. Live well means we should be addressing their care, data and ageism, which we'll be seeing. So anyhow, because it's a topic, and by genetic fault, we always start with a definition. So it won't be there are multiple types of definitions we get for healthy aging, but from a doctor's point of view or a medical perspective, this it's a simple definition I could get, and that is developing and maintaining the functional ability that enables well-being in older age. What do you mean by this functional ability? It has two aspects. A person, an old age person, if we can call him that he is healthy aging. He is undergoing healthy aging means he should have good physical and mental capacities, that is both cognitive as well as physical abilities. He should be good enough. Second thing is the environment. It's not enough that old person is very healthy physically and mentally, but he should be living in an environment, or he should be surrounded by an environment. Let it be a physical environment or a social or a policy wise. Policies means not only made by the government, it can be homemade policies also, or a state-wise policies. So all the environment and the interaction between these two, the environment and their physical and mental capacities are there. We can call the person is having, that old age person is having good functional ability, he is healthily aging. So now this globally, the global population is rapidly aging. When I use this statement, it definitely has a proof, which I'll be showing in the next slide. By the year 2050, it is projected that over 1.5 billion people, they'll be aged 65 and above, which is proven by this is the United Nations World Population Prospects who did. You can see by now it's the time of, sorry. Okay, you can see that the blue color represents the number of aged people. You can see the blue line. So after 2022 and all, towards 2050, when it goes to 2100 and all, you can see that the number of people who will be age 65 and above will be 5 times more than the pediatric age. Or if you look at in another perspective, out of the total population, if you see by around year 2010 or 2020, you can see that it's only 8 to 10%, which is going to become 14 to 16% of the total population is going to be people of elderly age more than 65 years. These two statistics is enough to know that we are going to deal with a lot of aging people, so we need to concentrate more on their well-being. And my topic today is mainly on, there are various aspects to ensure healthy aging. And one aspect which I have been asked to cover is on the nutrition, which I would like to call it as, the nutrition is one of the pillar of healthy aging. It's one of the pillars, but one of the main pillars of healthy aging. If you look at this logo that has been also been created by WHO as well as by the Government of India in consensus, you can see that for a proper healthy aging, you need physical activity, good quality sleep, you need to, they should develop good resilience to the stress that they are going to undergo various types, as well as they should have very good social life also. We think that environment means putting them into a place where physically all the aram things are available. That's not the thing. Social connections also are required, but you see what is there in the center. It is definitely a nourishing diet or a nutrition. It plays a major role in ensuring healthy aging. So why is it called a major pillar? Because it's one of the very powerful. Why do I call powerful? You ask, we go to a doctor, they say that please do exercise, walk 45 minutes. Yes, we will walk. But you ask to change them only the diet, we are very happy. We can sit at home, we can add something, whatever possible. So it's a very powerful and a modifiable factor. It has been proven to slow the biological aging. It is also shown to preserve the brain function. We know that cognitive decline occurs in the form of cognitive decline, memory loss, dementia, etc., and sleepless nights. All these things have been shown to be improved, and it extends the healthy lifespan. And the recent large-scale studies have shown the references I will be giving in the end, few I will be showing in the slides. They link the diet quality, depends on the diet quality. 86% odds ratio was, there is 86% higher odds of healthy aging, which is free of chronic disease by the age of 70. This has been a proven thing. Now coming to the main part. See, whenever we deal with, when I say that eat this, when I'm going to present something, eat this, healthy aging, it slows your aging. It should always be an evidence-based thing, because we follow, we believe, and we would like to practice also evidence-based medicine. This is an era of evidence-based medicine. So if you go and search for this topic, you will get some minimum 100 slides I can make on what are the nutritional interventions we can do, but that doesn't make any sense at the end. So only the evidence-based things which have been, evidence in the sense either by clinical trials or a meta-analysis of multiple studies, only have been taken and been put here. Okay. So to understand that, we need to know the hallmarks of aging. What do you mean by hallmarks? Hallmarks means the biochemical level or metabolic level or molecular level changes that lead to this aging. It's already been covered yesterday by Rama Devi madam as well as by Akila Prashant madam. I have heard these talks. Akila ma'am was also skipping the thing, so I have removed my 7 slides because after hearing this. So I'll just put 1 slide and I'll try to finish because it's a little biochemistry. You know that. So it will be little ABCDs and all. So let's see this. So there are 12 hallmarks of aging, in which you can see whatever is given in the black background, that is genomic instability, telomere attrition, and epigenetic alterations. They remain the gene level changes that lead to aging. Next comes the blue things, that is loss of proteostasis, disabled macrophagy, and mitochondrial dysfunction. They remain the organelle level changes that lead to aging. Now come to the cellular level, that is cellular senescence, that is the cells getting dying, cellular senescence, and the stem cells getting exhausted as we age. They are the cellular level changes that lead to aging. Now coming to the 3 things called as altered intercellular communication, deregulated or dysregulated nutrient sensing, which is one of the important things for today, as well as the low-grade chronic long-term inflammation that sets in from the day we are born, which ultimately accumulates as a chronic inflammation leading to aging, which we use the terminology called as inflammation leading to aging. These 3 are the system level changes that lead to mechanisms that lead to aging. And the last one, which is the hot topic of today, for people whoever is interested in research, that's called as the gut microbiota. The changes in our gut microbiota has got to do a lot with aging and multiple diseases. That's called dysbiosis. So these are the 12 mechanisms or the metabolic changes that occur inside the cell at various levels, which will inside the cell or at the various levels, which lead to aging. So whatever nutritional interventions which we are going to say, there should be some proof that they are acting on some or the other of these mechanisms. Then we can take home something that yes, whatever I heard today is believable. So for that purpose, I have put these are the mechanisms for which. So I told you, don't get afraid by seeing all these pictures. So these are the molecular level which I have told you. Genomic instability means there are very extraneous factors like if you get exposed to chemical radiations, etc. Then intra things is production of free radicals. A lot of endogenous and exogenous things can cause genomic instability in the form of mutations, etc. So the best example is you all would have watched the Hindi movie called Pa, in which Amitabh Bachchan acts, and he is suffering from a disease called as Guilford progeria syndrome. That's due to the deficiency, the mutation that occurs in a gene that codes for a nuclear protein lamin. Now it is a proof that a genetic mutation causes a prematuring disease. Second thing is telomere shortening. Telomeres are the ends of chromosomes, all of you know. They keep on shortening as you age, and there is an enzyme called telomerase which prevents it. But this telomerase enzyme is not present mainly in your somatic cells, but in the germ cells they are present. So in short, as we age, telomeres get shortened. That also has an implication on your aging process. The third one is epigenetic alterations. Mainly there are histones which get deacetylated. Okay, deacetylation that occurs, and that will lead to aging. In one line, I would like to finish all these things. Now coming to the next three things: proteostasis, autophagy, and mitochondrial dysfunction. In our body, in our cells, as we age, lot of proteins, after they do their functions, they have to be destroyed, in simple terms. So they undergo destruction of that is a needed mechanism that gets destroyed by two things. One is lysosomes, we all are aware of. Second is the most important thing is the ubiquitin-based proteasome system. So this has to happen, but as aging occurs, we have seen that the capability of these two systems to destroy the unwanted proteins is becoming less and less. That's called as loss of proteostasis. The proven things is that in many neurodegenerative diseases, you would have heard of some, we would have studied in our thing, that fibrillary proteins, tau proteins, a lot of proteins get deposited in various parts in various diseases. They are all proteins that are produced because of this loss of proteostasis. So we can correlate them to the neurodegenerative diseases that occur in the aged people. Now coming to autophagy is also almost the same, but it relates not only to the protein, the whole organelle also has to be destroyed at some times. It happens to autophagy. That also, when it gets compromised, aging symptoms come. Now coming to mitochondrial dysfunction. Mitochondria is a place where leaks occur, electron leaks occur, and what happens is that lot of, in simple terms, free radicals like superoxide and free radicals are formed. They will go, and you know that oxidative stress is a cause for all these things. So that also is well known to cause. Now cellular level, cellular senescence, that means as we age our cells become older and we call senescent cells or zombie cells. And these zombie cells are well known for secreting lot of inflammatory cytokines like interleukin 6 and tumor necrosis factor alpha and all. So they are also very well known to produce this chronic low grade long term inflammation leading to inflammaging and aging. Next, stem cells get exhausted. There are a lot of nutritional interventions that have been studied to stop this stem cell exhaustion, which I will be putting a slide on. Intercellular communication. Hormones like insulin like growth factor, then many other hormones like dopamine, they all can act only with the help of their receptors, which are present mainly on the cell surfaces. So cell-cell interaction is very important for much of the hormones to function properly in our body. So what happens is when that intercellular communication is lost, again it leads to some aging processes. So these are the things. Only one that I have left is this nutritional thing. So this part you need to listen, this thing. So what happens, there are a lot of metabolic signaling pathways, mediators like insulin like growth factor, then mTOR pathway, which I'll put the picture in the next slide, sirtuins, a certain type of proteins, AMP activated protein kinase, and FGF21. Don't get carried away by these names, it's nothing. If you look at this, what happens is you can just, which is the, this thing? Not next, the highlighter. Okay, so you can look at that red thing, this glucose. If you, the food, these are the pathways that are acting. So if you can see three main things in the center, one is mTORC1, the other is AMPK alpha, that is AMP protein kinase, SIR2 This AMP kinase and SIR2 they both activate each other, they both are very good, they are required, their activation is very good to prevent aging. But mTOR1, if it acts too much, just take off only the, it will actually cause aging. So inhibition of mTOR is required for anti-aging. So this is a basic mechanism that works where you can already see lot of things being acting. We'll come to that when we come to the dietary. So in short, whenever all these nutrient sensing pathways will get activated, and with the help of these proteins by name ATG, phosphotranscription factor, S6K and all, they will do all these things, whatever we have spoken, whatever are the mechanisms, they will be affecting them. Now coming to one slide I have to put because this is the hot topic of research going on, gut microbiota and aging. The nutritional connection, the health of our gut microbiome plays a very pivotal role for aging, impacting immunity and the brain function. No problem. Okay. How much ever we grow, now we know the use of human brain and what is it, electronics. Okay, so with that, let's continue. That's unavoidable. So I would like to speak about the gut microbiota. What are the microbiome changes? Aging, what happens with aging is the gut microbiota composition, it will change, which will enhance the gut barrier permeability, it increases inflammation, it weakens our immune responses, as well as the blood-brain barrier will be opened. It enters the brain, neuroinflammation, and results in gut microbiota. Lots of studies have done with neurodegenerative diseases. So hence, definitely with aging too. Second thing, so the role of probiotics and prebiotics we'll be discussing in the next slides when we go to the interventions. The role of fiber-rich diet itself, we know what is the role in the promising frontier. It's in anti-aging research. The microbiome targeted nutrition is anybody who is interested can take this research. So till now, whatever I was speaking were all the changes that occurs that lead to aging. So when these aging mechanisms occur, so they are all being found to, see the genomic instability. These are all the words that are taken from the research articles. They are found to have higher cancer predisposition and impaired DNA repair, cellular senescence trigger and cardiovascular risk marker. It is epigenetic alterations it's a reversible target, but it is happening. Proteostasis can lead to Alzheimer's, Parkinsonism, cataracts. When you see whatever is seen in the right side, all are related with aging. Accumulation of dysfunctional organelles and proteins. And the most important thing that we were speaking is deregulated or dysregulated nutrient sensing leads to diabetes, obesity, and metabolic syndrome. Sarcopenia, that is nothing but the loss of muscle power and the thing with aging. That's called sarcopenia, fatigue and cognitive decline. Then inflammation, frailty, then impaired tissue regeneration, anemia and immune system coming a little low during aging, endocrine dysregulation, CVD, dementia, diabetes, and all these things. So these all mechanisms are proven to cause all the expressions of aging. Now when we think of, this is all under what we study under the microscope or all the mechanisms. Now let me think, what are the main common chronic diseases and ailments that come to our mind when we think of somebody is aging? The things that come are, one is all the comorbid inflammatory diseases like coronary vascular diseases, diabetes, hypertension, CKD, etc. Other than that, vision, cataracts start coming. Then we get Alzheimer's and dementia. Then reduced sleep, which is the most common thing. Next, sarcopenia, that means muscle mass is lost and the function of muscle is lost. So arthritis and osteoporosis and arthritis. So these are the chronic diseases that come. Now coming to our nutritional interventions that to maintain the cognitive and physical vitality. So whatever interventions we are going to speak, it will be focusing on combating inflammation, oxidative stress, sarcopenia, cognitive decline and frailty. So let's see, this is in short. Okay, I'm just summarizing, not summarizing, I'm just enumerating caloric restriction. This is the first thing which we'll see in detail. Second, periodic fasting. Third, antioxidant containing foods. It can be vitamins or it can be polyphenols. Certain vitamins, if you put into research and see, all vitamins will appear. No vitamin is left out. But the ones which have been proven and with a lot of research evidence, vitamin D, B12, followed by niacin, NAD, calcium and zinc, the minerals. We all know about the role of omega-3 fatty acids, or clearly speaking, omega-3 by omega-6 ratio is more important. Lutein, zeaxanthin and beta-carotene seen in various types of foods. Prebiotics, probiotics and symbiotics. Resveratrol, which is an agonist of SIR2 it's very, very important. Spermidine, it's a polyamine rich foods. Berberine, luteol, and luteolin in carrots and broccoli. And curcumin, that is in turmeric and gingisenoids. And next is combining all these things, that's called anti-aging diet. This is what we are going to see in the next slides. First is the most important thing. If you take anti-aging, any intervention, they'll give the first word that will appear will be caloric restriction. So caloric restriction is, it's found to have very good anti-aging potential. So how do we define this caloric restriction? Caloric restriction is nothing but if for a particular age, whatever is the recommended calories, in the 25 to 30% you have to reduce. Such type of diets are they are called as caloric restricted diets, and these are the diets that have been found to be useful for against aging. So it reduces the nutrient mediated release of all those hormones I told, growth hormone, insulin and insulin growth factor 1. It inhibits mTOR signaling pathway, it enhances autophagy, it enhances sirtuin proteins, and it also enhances the FOXO transcription factors. Just don't go by the words, these are all required for a good anti-aging. It improves the insulin sensitivity, it reduces the risk of metabolic diseases. So let's see, the same picture again comes. You can see when I do the caloric restriction, what happens? Glucose is less. We are taking less carbohydrate. So glucose is less. So what happens? Glycolysis decreases inside the cell. NAD will increase. So if NAD increases, what happens? It's NAD dependent protein, sirtuin gets activated. That is actually an anti-aging thing. Now coming to the left side, when glucose is decreased due to the glycolysis, less glycolysis, AMP or ADP by ATP ratio also changes, which will activate the AMP kinase. That can also is anti-aging. Next comes, you look at this one. Normally when insulin growth factor gets activated, it comes and activates mTOR C1. But whenever there is a caloric restriction will inhibit the insulin growth factor and mTOR C1 gets inhibited. So if mTOR C1 gets inhibited also, what happens is your aging processes, the mechanisms that lead to aging will decrease. This is the proof for what is the science behind caloric restriction acting as an anti-aging mechanism. So human studies have demonstrated that improved lipid profiles by doing caloric restriction, reduced inflammation, favorable epigenetic markers. Considerations, you know that. Now the problem is, when I speak about all these things, think of the thing. I'll give an example. You are eating so much of food daily. I'm asking you to reduce the calories to 30%. If it is me, I'm not telling you people, if it is me, I'll start crying. Exactly, I'll start crying if I am restricted from taking some food, because I am a person who lives for food. So caloric restriction is not so easy as you think as you can do. But understood. There are multiple studies which I'll be showing in the next. See this one, before that, let me show the studies. So this is one important study, the most important study of caloric restriction. It is in Okinawa. All of you will be knowing what is the peculiarity. It's a place in Japan where the highly aged people, that means 100, 105, and the aged people lived in the world. One group is Okinawa. So they conducted a study in this Okinawa population, and they found that they didn't do any, a clinical trial in them. They just went back and checked how much calories they were taking when they were young and when they were in the adult life. Their calories were found to be very, very less. Less carbohydrates, little more protein. So they have just told that definitely caloric restriction has a major role in aging. Second comes another important study called calorie study, where 25% caloric restriction intervention. This was a clinical trial where they tried for 30 years. They tried with the people, with two groups, nurses as well as one health care workers. For 30 years, they prospective study where they did the restrictive study. But the funniest thing is that after the study is over, when they went back and checked, did they do 25% caloric restriction? None of them were. It was only 10 to 11% of caloric restriction they were able to do. But even with that 10 to 11% of caloric restriction, they were able to. It showed evidence of anti-aging markers aging markers coming down. So don't think that when I say caloric restriction, restrict to 25 to 30%, it is easy. It's not easy. So what is the way, before that, so there is one more word called as CR mimetics, caloric restriction mimetics. Mimetics is nothing but some foods, when they tried, it simulated like caloric restriction. These are the foods, these are the compounds, and these are the mechanisms that they were found to be active. If you see, is it feasible? I thought of not putting all the foreign names here also, because we don't have access to that. Grapes, berries, peanuts, we have access. Green tea, turmeric, which contains curcumin, onions, apples, quercetin, broccoli sprouts, wheat germ. That is one of the important things that we get nowadays in our big supermarkets and all. It's available like a powder. You can make your roti or chapatis with this wheat germ powder. It is found to have very good anti-aging effect. Legumes, fatty fish, it contains omega-3 fatty acids. When you are speaking about omega-3 fatty acids, let me put a word. There was a comparative study between two group of people whom omega-3 supplementation was done, and in another group they have supplemented them with food that contains omega-3 fatty acids, nothing else but fish. Okay, so they have found that people who consumed the sources or the food that contained omega-3 fatty acids showed very good results as compared to, I'm not going against the pharmacy companies or anything, but as far as possible try to consume it in the form of the food source that it contains will be better than going for supplementation. Then you will ask, what about vegetarians? You have to go for, this way only. So the tablets only. Eggs, soy, fermented foods like probiotics, all these
are medicines which acted like caloric restriction. So this is one. Now I told you, caloric restriction ketale, we are having an affair. Is there any other way to translate it into a feasible way where human beings can do the caloric restriction or get effects similar to caloric restriction without restricting your calories 20 to 25%? The answer to that is called, what is it? Periodic fasting, which all of us are very aware. We call it as intermittent fasting. Many of us will be trying also. Here there are many people who are trying, whom I know. So periodic fasting. There are many types. There is one alternative day fasting diet. Don't ask me, is it feasible and all. These are all there in the thing. Alternate day you fast. I cannot even imagine. Second thing is 5:2. That means 7 days left. 5 days you eat proper food and 2 days you fast. This is one type they are telling. Third is 48 hours fast once a month or twice a month. And the last one is the best one, which I would prefer. I have tried. That is called as what you call it as what diet? Fasting? Intermittent fasting, that is the daily time restricted feeding, that is 12 to minimum 14 hours of fasting. You need not do anything more than what you are doing. You can have all the food that you are having, but only thing, evening before 7 o'clock close your kitchen. But that means you complete you have your dinner before 7, and next day morning, only problem you will have is the people who are addicted to the early morning coffee or tea. That also you are not supposed to. Wait till you reach your institute, 8 or 9, then have your breakfast. That will count for 12 to 14 hours of fasting, and it has been proven to decrease lot of things. The living example is standing before you. I have also tried for many months. Lot of my parameters have come down with that. So that is one thing that has been. What is the basic thing behind this? Whenever we are restricting food, that means carbohydrate diet is restricted. Usually our energy comes from the breakdown of glucose, the first one. So when you restrict glucose, it goes to the fat metabolism. It starts your adipose tissue mildly breaks down, releases fatty acids, they undergo oxidation, acetyl-CoA comes, it goes for ketone body formation. And these ketone bodies are another source of the fuel for our body. So by doing all these things, what they want is that changing the energy source from carbohydrates to fat. That's what is your famous paleo diets and keto diets, which I won't be speaking on. So next, it has been proven that even periodic fasting, it has reduces the risk of developing lot of diseases like hypertension, cancer, CVD, neurodegenerative diseases, Alzheimer's. Many are in mouse models, some are in human trials are still yet going on, but all these diseases there is proof. So just to give you an idea, when you say that this is a normal diet and this is a calorie restricted diet, not all purpose, total means normal diet for a person, for an adult is 1900 to 2320 kilocalories. If you want to go for a calorie restricted diet, it has to be reduced to minimum 1300 to 1800. Got it? Now you have an idea how much food you need to decrease in that. In normal diet, the calories will give for carbohydrates will give contribute 55 to 60% of the energy. There it has to be reduced to 45 to 50. Proteins, normally we learn it as 1 gram per kilogram body weight. It has to be increased to 1 to 1.2, or if there is any coexisting diseases, little more. Fats, 20 to 30 calories that we are increasing in this diet. You can see that is the peculiarity. We increase the fat little more, decrease the carbohydrates. Protein also will trend to increase. Fiber has to be increased little. Micronutrients in our normal adult diet will be adequate RDA. But here we need to focus on some vitamins which has to be supplemented more. B12, vitamin D, niacin, and some minerals like zinc, etc. Now this is the main differences between these two. Just for a meal pattern also there is a small differences will be there. Same thing. I am not going through each one, but you can definitely see that there is some difference. The important thing, red meat or processed meat, it is allowed in our normal diet, but it has to be reduced in this. And when you look at the healthy fat, you can see omega-3 fatty acids has to be increased. More importantly, it's not the amount of omega-3, it's omega-3 by omega-6 ratio that has to be concentrated more on for getting good results. Okay, with this, I move to my next one, that is antioxidant containing foods. So, we all know that blueberries, how many have access? I don't know. So, let's go to the next one. Strawberries, is available in Indian markets. We all buy that. It contains vitamin C and lot of anthocyanins. Black grapes, this which I'll be putting in the next. Please understand, this is a take home. Black grapes, don't go for green. Black grapes as a resveratrol, which is the main person who is going to make you look young for years. Okay, so next is pomegranate, which has anthocyanins again, green tea, which has EGCG, coffee. And the next one is the most, another interesting point. What is that? Dark chocolate. You would have seen whoever is fasting, whoever goes to the gym regularly, they carry a dark chocolate in their pocket. That's become a fashion. That's bitterest, the most bitter chocolate. Why? Because it has more than 60% of cocoa is there, and it has been proven to mainly your age-related. Nowadays, if I ask her name, after some minutes, I'll forget her name. That is in this age. Aging has started. So, that cognitive decline and memory loss, very good studies are there. I'm not promoting dark chocolates here. Then, tomatoes which contain lycopene and vitamin C, carrots, spinach, broccoli, red cabbage. See, I see one thing I'll tell, till now I have put many slides, but the madam has taken the pick of this slide because now you know what is the role of antioxidant containing foods. Nuts, especially almonds, they contain vitamin E and polyphenols. Walnuts, it contains melatonin, that is there, only there. Melatonin is required for proper sleep. So sleeplessness which the people suffer with age, walnuts and milk is also very good. Milk, that's why we say that give a glass of warm milk before you go to sleep. So that's all good for sleep. Sunflower seeds which contain vitamin E, turmeric and garlic which is a part of the anti-inflammatory diets which some people are following nowadays. Ginger, olive oil, whole grains, that is important, oats, all the other things. Avocado, you know what is the rate, but still it's good. It contains glutathione, good for skin. So ladies will go for avocado. Legumes, polyphenols and flavonoids are there. Red wine, again it contains resveratrol. Okay, they are promoting red grapes and red wine. So please, I won't speak about this. This is the proof of which are the mechanisms that are affected. The food sources and the flavonoids have already put. So these are the mechanisms where these food items act, helping us in anti-aging. Curcumin means there's a thing that you see in turmeric. And the second one, ginseng, at least some people who have watched Korean dramas would have heard of ginseng. Ginseng roots is very costly root thing. It is considered, they keep it in their safes, in the locker. I have heard that it is much costlier than the real quality ginseng, than diamonds I have heard. So I don't know about all those things. But ginsenosides studies are there that they as well as curcumin have shown very good results with anti-aging properties. Now coming to our resveratrol. It is an agonist of sirtuin-1. In most experimental models, it suppresses inflammation, oxidative damage, tumor production, immunity it improves, mitochondrial function it improves, against cancer. Okay, so this is the thing, resveratrol. The most important is being red grapes or the one what we call as black grapes. Along with it, some more things are there, that is the chocolates are also, that is cocoa is also good for, contains then I checked what are the other things other than red grapes. Huckleberry, I don't know what it is, but wine, raspberries we get, pistachios we get, peanuts we get. All these also have, but the good richest source always remains the red grapes. Okay, so resveratrol is, so this is the main study where resveratrol has got so much of importance. This is the study. Spermidine, it's a polyamine which induces autophagy and extends the lifespan, neurodegeneration, cardioprotection. Neurodegeneration is prevented and cardioprotective. It has positive effects on cognitive function of older adults and on blood pressure maintenance also. Spermidine foods are wheat germ and these parmesan and cheddar cheese that we use for various purposes in our house, broccoli, cauliflower, green peppers, spinach, soy products and mushrooms. They contain spermidine in good amounts. So these, you can see spermidine acts on all the hallmarks of aging, if you see. So this is a study that supports the spermidine effects on aging and age-related diseases. Now I told you in stem cell, see these are all the various nutrient factors that are under study, and the strength of evidence also has been shown, either human studies, animal studies or clinical trials. You can have an idea. In that definitely you can see that urothalin as well as caloric restriction has very strong animal as well as human study support for the thing. Spermidine is also having a moderate animal plus epidemiological support. So these are about things. Now coming to prebiotics, you know what is a pre and a probiotic. Prebiotic is the non-digestible food substances that if we take, our organisms that are present, that is the probiotics can grow. So the food for probiotic is prebiotic. And the next one is probiotic. Probiotic are the live organisms which when administered in adequate amounts will confer a health, especially Lactobacillus species, Bifidobacterium and Saccharomyces boulardii. So combining these two things, there are combinations of prebiotics and probiotics, that is symbiotics. Prebiotic you get in your yogurt and probiotics is inulin. It's a polysaccharide of fructose. Okay, so they are also found to have good impact on aging. So they reduce inflammation, improve immunity, metabolic health is supported, gut barrier integrity is maintained so that it doesn't cross the blood-brain barrier and cause neurodegenerative diseases, and it influences the gut-brain axis. Next, these are the main components I have said. Now while you are planning a diet for an elderly, keep in mind only three things. Carbohydrates, mostly go for complex carbohydrates, don't go for refined sugars. 55 to 65% energy, 1 to 1.2 or 1.2 to 1.5 gram per kilogram body weight. Depends upon you are a healthy old age or with a comorbid condition. Protein should be little more high. This leucine, isoleucine and valine I put, they are branched chain amino acids. Some studies say that they are very much against aging. They create problem, they fasten aging, but there are contradictory studies also telling that they have to. So we can't take that thing. Branched chain fatty acids, leucine, isoleucine and valine have contradictory results regarding aging. Then omega-3 fatty acids have to be supplemented. And coming to the water, the minimum, they should be well hydrated, 30 ml per kilogram body weight. Water has to be given. So this is for better sleep. I've already put melatonin is required. It's present in walnuts. Tryptophan is required because tryptophan goes and produces serotonin, which goes to produce melatonin, which is required for sleep. That's why the milk and your egg comes. Magnesium, calcium, potassium, the three minerals that is very much required for your proper sleep, especially while aging, that is present in your almonds. That's why we said nuts are very important. Milk and curd will give calcium. Bananas and avocados rich in potassium. And vitamin D, as you know, in fortified milk and fish. And sleep, even other vitamins also support sleep. 6, B12, omega-3 fatty acids, GABA as such, and some apigenin and theanine. They are the compounds that are found in these chamomile tea and green tea, which are being advertised so much. So those are all the supporting research evidences which they have done the study. These are all single studies. Now coming for cognitive vitality. Again, cognitive vitality means whatever you speak something, after some time if you go and ask, they won't be able to recollect the same thing and correct it, say it again. That's the cognitive decline. Omega-3 fatty acids, B12 folate, B6, vitamin C and D, you can see how they act also. The benefit is they improve memory learning, they prevent cognitive decline, mood and cognition will be improved, slows the aging, then memory support, attention and memory, and better processing speed. This processing speed get decreased with age. That also is improved. So I need not explain each one things. These are the food sources and these are the vitamins that are shown to be. Now coming to, now the last part of only 3 or 4 more slides I'll be completing. That is the dietary patterns. Till now we saw these are the mechanisms of aging. These are the foods which will influence each mechanism and decrease the aging process. Now we'll come. We cannot go and tell that eat this only, eat that. We have to give. So better is we prepare what? A dietary pattern. So there are many dietary patterns which we have heard. In that, the gold standard for aging, if you put even today, it stands as Mediterranean diet. Though the word is Mediterranean, because it started from the Mediterranean countries, they started following it up. So it is emphasizing on, we have to customize it to our Indian standards, available foods. That's the only difference that we need to do. But what is this Mediterranean diet? It emphasizes fruits, vegetables, whole grains, little olive oil, must they are telling, nuts, fish, moderate dairy and low red meat. They are not exclusively avoiding anything. Fish is required, red meat very low. So it should be rich in antioxidants and anti-inflammatory properties. Okay, so you can see next DASH diet, which all of us physicians are very well aware about that, for reducing, it was started for reducing blood pressure. So this is also have to be found to improve the cognitive function in older adults, and it supports vascular health also. Now comes to the next one, that's called as AHEI, that is index. What we do is, it is scientifically shown to reduce chronic disease risk. Okay, it's a plant concentrated, minimally processed and anti-inflammatory type of food. You look at this, there is a scoring system. what we do is you go to a patient or an old age person, you ask these questions. How many servings of vegetables do you take a day? How many servings of fruit? And please put the numbers and give the scorings. The scoring system can be 0 to 110. More the scoring system, they are very healthy. That is the meaning. Usually you get around, if Indians and all, lot of studies, they are coming around 50 to 60 or 70 maximum. They don't cross 75 in this AHEI score. But as you increase the score and you change their, their dietary pattern, it's good. That's why, that's the plus point of, it's not a very strong, this many grams, nothing like that. Accordingly, you can keep on grading their food pattern on daily basis. So this is one diet, then anti-inflammatory diet, which is going on very hot thing, which contains antioxidants, polyphenols and omega-3 acids and fiber. That also modulates the inflammatory signaling pathways. This is how an anti-inflammatory diet, this is how a DASH diet looks like. Okay, this is not for to by hurting. Only thing we see is in DASH diet, the sodium, you can see that they'll specifically tell about the salt content, how much they can take. Anti-inflammatory, if you see, mainly it will be having ginger and curcumin, definitely in that, with whole grain roti, etc. The chia seeds, everything will come into the play in this anti-inflammatory diet. So this is how this anti-inflammatory diet, DASH diet. Now, so we have heard of lot of nutrients, lot of dietary patterns are there. There is only a single study, if you search in your literature, a study that has compared multiple dietary patterns with aging. So in that it was published in the year 2025 in March 24th, where the health outcomes of more than 1,05,000 women and men aged 39 to 69 over the course of 30 years this study went on. And the result, these are the 8 diets that they compared, and they found that this AHEI, what I showed as scoring system diet, that was the one which was found to be the best, which showed best anti-aging effects, followed by planetary health diet index. This is just for an information, though we are aware of lot of dietary patterns are there. This is one study with proof. This is the article in which they presented this, and this is the Nature Medicine article that comes with healthy aging. This is the last slide for me, the second last. So with all these things, what we say is that, see, aging cannot be managed or intervened just by giving a diet, just by giving some medicines, just by taking care of their physical vitality. It's a multifactorial thing which has to be integrated and it has to be delivered. So many integrative models are there. The best and one thing which I found was called Amal model, that gives some 7 criteria. In that, one criteria is nutrition. So always you go for take this model, and in that model try to put whatever dietary interventions you can put. Next is precision nutrition. This is the future of nutrition. It is multi-omics, that is genomics, proteomics and metabolomics. That means each person, we take the blood, go to the genetic level, see what is the problem, which mechanism, is it mTOR, is it sirtuin, is it which mechanism, CAMP, which pathway is problem, and give them foods. That's a long way to go. That's called as precision nutrition. And let me conclude that nutrition is not just about sustaining a life in old age. It's a very powerful tool to shape our future health. So embrace the evidence-based dietary patterns, integrating only evidence-based. Integrating, don't go for any diet that anybody comes and walks in your YouTube or any patterns. Integrating the key nutrients, leverage personalized for each person, balanced diet strategies for lifelong vitality, and there is nothing called as one size fits all. One diet pattern you copy, everybody follows that. There is nothing like that. Everybody's body is different, weight is different, comorbidities are different. So there is nothing called one size doesn't fit all. Common theme should be, whenever you are selecting a diet, plant forward, that means more vegetarian food, nutrient rich, low processed foods, combining Mediterranean DASH, AHP, whatever principles you know, take the best of that and make a diet of your own name. Okay, Dr. Manju's diet, you can make one thing like that. And early and sustained, that's the main thing. You want to treat aging, you want to make our old age people healthy. I will go at the age of 64 and intervene. Nothing is going to happen. So whatever dietary interventions I have spoken here should be started from the mid-adult age. That means I am little, youngsters used to start from little more elder age so that your physical strength and cognitive function will be preserved when you get into old age. So you start today for a healthier and a very sharper tomorrow. Eat well and age well, and nutrition is your strongest pillars. So these are the pictures. Thank you.
It's been a pleasure to sit through the session and listen to you, ma'am. And it was a very energetic session. And thank you for making this session very lively. And if you, the session is open for discussion. If you have any doubts, you can ask. And you can also ask this a doubt through the Zoom chat online. You will have a minute and you can ask your doubts. You can also ask in the group if you want.
Yes, I expected this, sir. I came prepared, sir. So, keto diet, you don't have doubt with paleo, no? Thank you. Okay. So keto diet is also same things. It's nothing but what they do, the problem with keto diet is, in keto diet they're completely avoiding carbohydrate. You reduce carbohydrate, give this, it has a biochemical basis. That much I can tell. But there is no thing of a long-term effect of this keto diet. So now it is working, temporary things, lot of people are saying that their HbA1c has decreased, their lipid profile has come down, then lot of things they are telling. Sir. But we don't know the long-term effect, but when we check the biochemical basis, it's okay. But one thing that is preventing it is, we are completely changing it into keto. They completely avoid carbohydrate, nil carbohydrate, high fat and medium protein. That is the basis of keto diet. So as per biochemistry, a ketone body is used for the energy purposes, but for a short term, that short term in the sense 6 months you do, definitely body weight is decreasing, no side effects, all those things are there, but long term effects, no idea. So I didn't include it. And aging, I checked. In aging keto diet, they have studied, but not very, statistically significant differences, they couldn't find it out in this thing. Oh.
Any more doubts?
Olive oil. See, I don't know. That is also, again, they'll tell them olive oil is of multiple types, you know, virgin olive oil, all these olive oils are found to have mainly, one is some important antioxidants, you know that. Antioxidants are, and certain polyphenols are also there. So it was started, when you see, when I was preparing, I just checked. More than what I presented here, thanks to the organizers, I got to read more about all the nutrients that we are having. These studies on olive oil started from the West. You know that we are not used to the oils. But once it comes in a scientific thing, they have ample amount of proof that on and various types of chronic diseases, not on only this thing, on weight reduction, on metabolic syndrome, on obesity decrease, the two after surgery, obesity after liposuction. There is a study of using olive oil based foods after liposuction in preventing the fat from reforming. So there are multiple things, but in aging also there is there. So they are correlating that when all these chronic conditions are not occurring, or the chance is very less, or the markers are found to be decreased. So they are correlating that it can be used for, it plays a major role in preventing or delaying aging also. That much. More than that I have no idea, but because it has entered our Indian, industry, we are all buying. So we have to wait and see, that's what.
Any more doubts? Okay.
I don't have a doubt. Hi, ma'am. Ma'am, it was an excellent session, ma'am, with magnificent information, ma'am. Definitely it is very, very helpful for us, as I'm not an youngster, but when someone asked me, like, asked my age, I was a little bit hesitant to say my age, but now yes. Yes, ma'am. No, I'm very proud.
Why are you hesitant in telling your age?
So now I'm very happy to say that.
There are a lot of prime ministers and a lot of big people who are at the age of 75, 80 who can work better than the so-called new Z generation, madam.
Yes,
so you should be proud enough if you are doing your work.
It was very, I got lot of information from your slides, ma'am, from starting from the genetic level, cellular level, molecular level. There are a lot of information are there. It was actually spinning in my mind actually. So there are a lot of, actually I had worked in one project which is related to gut microbiota, ma'am. So it was an Indo-Australian project where we worked like we used a starch. It was a human trial. So with proper
starch was used?
Starch. It was a cornstarch. So base studies with the gut microbiome studies, which with the legendary gastroenterologist person. And also there is one more study which we had done with the clinical interventions. whether nutrition have a more effect on this short chain fatty acids. So that is what actually, so that is one, in one slide, yes sir, yes ma'am, that's what quite interesting to see that, oh, there is a, as you mentioned like,
short chain fatty acids, it will go to coconut oil and the discussion will move on like
yes,
that,
yes,
medium
ma'am.
chain,
Yes,
that's why I
ma'am.
didn't bring
So
it too
yeah,
much.
yeah, it was actually when I did my work like that, like I was thinking like why it is happening, why it is happening, why it is happening. So all those questions actually answered in your slides, ma'am. So it was very nice to hear. Thank you so much, ma'am. It was a nice take-home message. Eat well and age well. Thank you so much, ma'am.
Fasting. There is a question from the audience, it seems. What is audience? The question is, what about diet?
Diet is fine. How about fasting? Is it anti-aging?
Yes. The person, thank you for this question. And when we say fasting, that's what I told. Anything, when we make the final dietary plan for a person, it was very clearly written. If you take Mediterranean diet, or you want to take anti-inflammatory diet, or you want to take a AHEI diet, it is with caloric restriction, whichever form. Is it okay for old age? Means, see, as age advances, we start doing this, our body gets adjusted to this intermittent fasting if we start doing it from the middle age itself. So it won't be a problem when you reach the old age. But if you want to start as a new in the old age, after 60, 65, the person who has been eating properly 3 times a day, suddenly you go and introduce fasting for 14 hours, it is not going to work, definitely. That's why the answer for that is that most of these interventions will be very effective if you start from the middle age. Our body gets used. Then there is nothing called as in aging, is it okay? The question doesn't arise at all. So I think I've answered. Thank
Madam, black grapes all of us want to eat, but it will increase the sugar, no madam.
That's what I'm telling you. We have to, see, they tell me
balance.
1 fruit a day is already given. It doesn't mean that we have sugar. We cannot take, because the diabetic is speaking, ma'am. So we cannot take any fruits, it's not there, ma'am. You just decrease the carbohydrate content of that day. Some rice, if you are taking 2 cups, means you take 1.5 cup and eat 4 pieces of grapes. That's all, ma'am. Don't fall for that always that it is sugary and all. Nothing prevents us from eating red grapes, ma'am.
Yes, thank you, madam. It was a very thoughtful presentation with good structural content. All the targeted information was presented in a very logical manner. And on a personal note, my husband is a cardiologist, and whatever discussions or rather arguments that we have are over food. And me being a vegan on ethical considerations, I was very happy about the plan forward concept. I always look out for less cruel alternatives, madam.
Yes.
On a personal note, madam, I've always admired you for your strong personality,
Thank you,
your
ma'am.
unwavering commitment to medical profession.
Thank you, ma'am.
We're very happy for your presentation.
Thank you so much.
Thank you, ma'am.
Now with that, we are winding up this session. Now I'm calling Dr. Ananthi ma'am and Dr. Suryapriya ma'am to felicitate the chairperson and speaker, and Dr. Pawan sir too. Okay, now we will have a short tea break. You can have, the refreshment is arranged outside. I repeat, we will have a short tea break. The refreshments are arranged outside. It's a 15-minute break. Please come back and join soon. Well, hope you all had your refreshments and got refreshed. And now we are continuing with this session. Aging is actually an inevitable phenomenon, but how we age, especially where our heart is concerned, is something we can influence. So today we are exploring that. And to lead us through this vital subject, we are privileged to have Dr. Joy M. Thomas, sir, who will be speaking on strategies to aid healthy cardiac aging. And to formally invite and welcome distinguished chairperson guiding the session, now I request Dr. Kalerasi to please come forward.
Good morning. Good morning, respected dignitaries on the dais and off the dais, esteemed faculty members and dear delegates. It is my great privilege and honor to introduce our chairperson for this session, Dr. Narayanaswamy sir. Sir is currently serving as a professor and head of Department of Cardiology at Saveetha Medical College and Hospital. We are truly delighted to have with us Dr. A.G. Narayanaswamy sir, who holds a diploma in child health and Doctor of Medicine. He is Diplomate of National Health, including a super specialty qualification of TNB in cardiology. Sir is also a member of National Academy of Medical Sciences and fellow of several prestigious international professional bodies like fellow of European Society of Cardiology, fellow of American College of Cardiology and fellow of Royal College of Physicians. With over 23 years of extensive experience, Sir has served in various senior clinical positions at the Government of India's prestigious Institute of Cardiac Treatment and Research at Southern Railway Headquarters, Perambur, Chennai. His primary areas of expertise include interventional cardiac procedure in both adult and children. In 2012, Sir was an observer at Royal Papworth Hospital, Cambridge, UK, where he gained advanced exposure to newer treatment strategies in heart transplantation. Sir was also an invited faculty member at 17th Seminar on Angioplasty of Chronic Total Occlusion held in Japan in 2016. Dr. Narayanaswamy sir has been a principal investigator in several major international trials, including POISE, PROMISE and CREATE, and sir has published more than 25 papers in reputed Indian and international index journal. Sir has contributed significantly to medical education as an examiner for DM and DNB super specialty examination and as an inspector for hospital accreditation or TNB cardiology course. Sir has delivered invited lecture at many prestigious institutions including PGI Chandigarh and has served invited faculty at numerous national and international conferences. In appreciation of his outstanding service, Sir has received the National Award from the Government of India in 2008. Sir has also served as member of Board of Studies at Chettinad University from 2014 to 2016. With such an outstanding and inspiring career, we are truly privileged to have him as chairperson for this session. Representing the organizing committee and all the delegates present here, I extend a warm welcome to Dr. A.G. Narayanaswamy sir. We are deeply honored to have you with us today, sir. Over to you, sir.
Thank you. Firstly, my thanks to Professor Anandi Madam and her team for inviting me to chair this session. I am delighted to introduce my friend, Dr. Joy Thomas, to this meeting. Dr. Joy Thomas is the professor and senior interventional cardiologist and electrophysiologist at the Apollo Hospital, Vanagaram. He has been an invited speaker to many national and international conferences. We are eagerly awaiting to your talk, sir. Dr. Joy.
No, this is the next one, sir. This one. Which is the pointer? Pointer, no, that's because LEDs can work. It's the LEDs, okay. Pointer works.
Not working. Good morning. First of all, I would like to thank Professor Anandi and the team who has organized this meeting for considering me as a speaker at this occasion. Now, I am to talk on aging of the heart. I just want to know, how many of you would like to live forever? Forever and ever? Huh? No. So at least one person is shaking their head. They don't want to. Two. You want to live forever? Okay, right. Good. All the best to you. Now, how do you change? Oh. Okay. Now, I got confused by writing this. Can you go back? This statement. I wrote saying by Confucius, but actually it is an old Chinese proverb. In my hurry to make the slide in the morning, I wrote Confucius, and the spelling is also wrong. So the saying is, better to be a diamond and be broken than to be a tile on an old house and to last forever. It doesn't mean to say that you should live short. It only means to say that whatever years of life you have, you must add life to this age, not the other way around. So it's, being 90 or 100 or 130 and living without achieving anything is not as meaningful as living short. And you will see many of the people who have made a mark in life, whether it is Gautama Buddha or whether it is Martin Luther King or Jesus Christ, or they all died young. They died at 30s and 40s. So, but they have made a mark in life. So that is what is important. So quality is important, not the number of years. Okay, doesn't matter. I'll manage from here. Yeah. Okay, so we are going to talk about the heart and how it is going to age. Now, this gentleman, Swami Sivananda, is a Varanasi-based yoga exponent. He was born on 8th August 1896. There's not much record, but this is widely recognized as the oldest living Indian. He claims to be 129 years. He was awarded the Padma Shri in 2022 for his contribution to yoga and follows a strict regimen of boiled food, no oil, salt, and daily yoga. So just think of it. Huh? Would you all like to do that? Not me. But look at this man. He's a Red Indian. Now, he lived, actually, later on, he moved to the reservation in the US, and he was 138 years when he was dead. But I don't think I would like to look like this when I'm old. I'd rather die when my face looks a little better than this. So, anyway, that is all a matter of personal opinion, okay? And how much you're going to work for it and how much you cherish what you have in your life. Now, going to biblical, Abraham was one of the characters in the Old Testament. He's recorded at several significant milestones in the Old Testament, and it is quoted several times. He was 86 years old when his first son Ishmael was born. 99 years old when God changed his name from Abram to Abraham. And at 140 years, at the age of 140, he married Rebecca. 175 years old when he died, and he was buried by his son, his second thing. I don't know whether at 140 I would be still alive, certainly not. But to think of another marriage at 140 must be really stupendous. We think that modern medicine, modern day, has given people more longevity. But the fact of the matter is, it was not modern medicine. It was good living, clean environment, and clean, food habits that kept these people alive for that much. Now, this picture shows Abraham going to sacrifice. He loved God so much, and God told, Abraham, do you really love me? So he said, yes. So then God said, then for the next sacrifice, you have to offer your son, not a lamb, to a sacrifice. So that's what you see. Abraham was very sad that he has to kill his only son, because at that time he had only a sack. He took him, and the son was carrying a lot of wood for the sacrificial altar. Then he asked him, Father, we have got the wood and we have got everything, but where is the lamb, sacrificial lamb? Abraham didn't say anything. Then he arranged the wood, as you can see there, put his son on that, and when he was about to sacrifice his son, the angel came and stopped him. So that's the story of Abraham, who lived till 175. And he was very obedient to the God, that's what he said. Now, coming down to brass tacks. Now, what are the trajectories in cardiac aging? It's a journey of the crossroads of inflammation and metabolism. Professor Manju has made my task very easy. Thank you very much for going in depth into all those things about epigenetics. Most of it goes above my head. My friend Narayan Sami will know better because he's a pediatrician and does more with genetics than I do. But all these basic sciences, in the milieu of cardiology, we have tend to forgotten. I have forgotten most of it. Now, cardiac aging is a natural process. It involves a gradual decline in cardiovascular function and leads to increased vulnerability to injury, such as ischemia, hypertension, metabolic stress. Accumulated age-related damage to cardiac cells is aggravated by abnormal metabolism, inflammation, very important thing, and senescence. This finally results in interstitial fibrosis, cardiac hypertrophy, vascular remodeling, and loss of cardiac. So some of the effects of aging on the heart could be at the cellular level, could be genetic changes, functional changes, and structural changes. What we see, most of it is functional changes in the form of decreased cardiac output. When we see a patient who has breathlessness and unable to lie down, work, that is we call it as heart failure. There is atherosclerotic cardiovascular disease, which we are very familiar with. Most of it known as heart attacks. So Narayan Sami just went down. He did a primary angioplasty for a colleague's mother today. So those are the types of things which we face in day-to-day life. Then, of course, cardiac autonomic dysfunction, which may be seen as reduced heart rate, which cause syncope, giddiness, and tachycardias, which cause giddiness. So from the clinical viewpoint, the healthy heart gradually goes on to a heart failure, preserved ejection fraction as age advances because of myocardial hypertrophy, fibrosis, and finally dilatation. And there is this age-induced arterial thickening. You look at the figure on the left side, you see that the lumen of the blood vessel is larger compared to the thickness of the vessel wall. But as age advances, the vessel walls become thicker and thicker. The tunica intima goes. Can get a pointer here. No. Pointer. No, I got it. So, just going back. So, you see here, the tunica intima is very thin compared to what you see here, and the media and the other things become thickened, and the external also become thickened. So, the wall become thicker, but the lumen itself becomes smaller. So, the trajectory towards cardiac aging are like the 4 horsemen of apocalypse. I think you all know what is apocalypse means. It means the end of the world, and it is some of the things which is written in the Bible, the day the world comes to end. Now, the 4 horsemen of apocalypse is a book written by Anthony D. Booker, who's an American author, and he has shared the 4 authors are one is a conqueror, then comes a peace breaker, famine, and death. These are the 4 things which lead to apocalypse or thing. And in the heart, the trajectory towards cardiac aging is similar to these 4 horsemen. So you have this one is sedentary lifestyle, one of the worst things. So sedentary lifestyle, calorie-dense diet, which are rich in calories. These are the 2 modifiable risk factors, and they go through this dysregulated inflammation, oxidative stress, epigenetic modifications, which Madam was talking about, metabolic imbalances also, and at intercellular and interorgan crosstalk, there is a thing which leads to cardiac aging. So, looking at the cardiac aging, you have these various things in a nutshell. You have cellular senescence, chronic inflammation, genomic instability, epigenetic alterations, which include telomere damage, mitochondrial dysfunction, oxidative stress, and dysregulated. All of this contributes to the cardiac aging process. So, cardiomyocyte senescence, so that an aging of the heart muscle itself is because of depleted nicotinamide NAD, dysfunctional mitochondrium, metabolic reprogram, and overproduction of reactive oxygen species. There, of course, is DNA damage and Whenever there are mutations in the DNA, the body, the genetic mechanisms automatically repair it and see that the DNA damage is not carried on, not propagated. But as this myocardial cell becomes older, this capacity to repair the DNA which is damaged gets reduced. So what happened is senescent pathways are activated with induction of various kinase inhibitors, and this leads to pro-fibrotic and pro-hypertrophic senescent associated secretory phenotype. And what this leads to is myofibroblast activation. As you all know, fibroblasts are the one that leads to the laying of collagen and fibrous tissue in the body, and this leads to myocardial fibrosis. Once the cardiomyocyte is replaced by fibrosis, the pumping ability to contract, ability to pump is reduced. Not only that, the ability to expand to receive blood is also reduced. That is very important. This is not only the pumping function, what is known as systolic function, but also the diastolic. Diastole is when the heart relaxes to receive blood. That is also important. So that is also affected. So you may have a person whose pumping function, they say ejection fraction is all right, but the person has breathlessness. It's because their heart does not expand and relax to receive blood. That is known as diastolic heart failure. So going on to next, you have inflammation, which is an important factor. Adipose tissue, the largest energy reservoir. Adipose tissue is supposed to be an endocrine organ and is one of the largest organs in the body. It plays a central role in developing chronic low-grade inflammation, and this ultimately leads to immunosenescence and energy dysregulation. This is particularly pronounced in obesity and diabetes through driving adipose tissue macrophage-derived secretion of pro-inflammatory and pro-fibrotic cytokines, insulin resistance, and aberrant adipokine production. So this is known as inflammaging. Madam has already alluded to that in her talk, so I will not dwell much about it. But suffice it to say, myocardial infarction, ventricular remodeling, because of a heart attack, the heart muscle dilates, and that is known as ventricular remodeling, and it can cause stroke and other age-related cardiovascular disease. Like coming to mitochondrial dysfunction and aging, mitochondrial dysfunction is a critical hallmark of aging. It's further enhanced by obesity and diabetes, changes in fission, fusion, mitochondrial DNA damage, and p53-linked senescence. This can induce senescence, promote apoptosis, and impair autophagy and alter cellular metabolism. Thus, mitochondrial dysfunction and its consequences are important targets in mitigating cardiac aging. It reduces the rate of myocardial DNA mutations and reactive oxygen species, enhancing mitophagy and promoting autophagy via the mTOR mechanism, and has shown promising results. So, boosting de novo NAD synthesis or supplementing with NAD precursors to restore NADH ratio or other anti-aging strategies. So there are some molecular strategies which are being looked up to combat this mitochondrial dysfunction, and also the use of mitochondrial MRI could also be explored to rejuvenate mitochondrial machinery. Of course, the mitochondrial dysfunction leads to calcium dysregulation, and this calcium dysregulation can lead to, along with myocardial hypertrophy, leads to some of the what is known as a person with a preserved LV but having symptomatic heart failure. Epigenetic alterations are the next ones. Again, this has been covered in the previous talk. I won't go much into it. That transcriptional regulation and genome stability offer protection against senescence, and thus they reduce oxidative stress through recoupling endothelial nitric oxide synthase, which are very important in the endothelial cell. So the blood vessels that feed the heart, that is the coronary arteries, are covered by a layer of endothelial cells, and nitric oxide synthase delivers nitric oxide there, which helps to vasodilate the coronary arteries. And this, whenever there is a problem with this epigenetic artery, this particular nitric oxide synthase is inhibited. So the aging heart through hypertrophy, apoptosis, fibrosis, contractile dysfunction, mitochondrial dysfunction gives rise and increased chronic inflammation goes into a state of myocardial dysfunction. Now, one of the methods of treating this reversing aging of the heart is xenotherapy, the removal of senescent cells. The accumulation, once the senescent cells accumulate in the body, they may undermine the adaptation to stress, potentially promoting heart failure, yet elucidating long-term beneficial effects of are especially linked to removal of senescent cardiac cells. So the senescent cardiac cells has to be removed in order to prevent the detrimental effect. So the detrimental effects of xenotherapy in cardiovascular diseases as suppression of senescence and cardiac fibrosis promotes cardiac fibrosis, myocardial infarction, and removal of senescent vascular, it actually aggravates the pulmonary hypertension. So the treatment of xenotherapy itself can be harmful, and they can lead to myocardial fibrosis and also pulmonary hypertension. So these things are being looked into nowadays. So we don't have methods by which xenotherapy is applied in clinical practice as of now because of these problems. Non-pharmacological methods, the reactivation of telomerase through endothelial progenitor cell transfer to enforce endothelial barrier function is one method. Manipulation of the epigenetic transfer of cardiomyocytes and reduce mitochondrial dependent oxidative stress is another method. And to reprogram human fibroblasts into cardiomyocytes into what is known as tissue engineering is another thing which is being looked out. And this engineered heart tissue transplantation represents a potential strategy for patients with heart failure and may deliver compounds targeting pathways involved in cardiomyocyte proliferation to drive regenerative programs. So, may not be always, it's not a good age to throw a surprise party when you have people who are more than 90 or 100, because the surprise may cause a disaster. So, what we have to do to reverse this aging is mainly, first thing what we mentioned was sedentary lifestyle. The second thing was carbohydrate-rich food, laden food. So to combat sedentary lifestyle, exercise is very important. 2 years of exercise can make you 20 years younger. So it could be started at any age. There is an English gentleman who started doing marathon running at beyond the age of 65. He never used to run it. He's a sick gentleman. I forget his name. But about a few years back, he did his, at 100 years of age, he did the marathon. So it's never too late to join, whether you're 65 or to start exercising. The benefit is for them. Of course, if you start doing these things at an earlier age, you're at a better thing. You're at a better handicap. But even at an old age, you can start doing exercise. And once you start exercising, the process of reversal starts. So now there are different forms of exercise trigger. That is, you can have high intensity endurance exercise. Now this is common in people who are in the IT sector, who have a 5-day week, and during those 5 days they work 14 to 16 hours a day. They don't have any time for exercise. So the weekends, you can see many of them on a bicycle, driving down to Mahabalipuram or to Pondicherry or some things like that. These are known as high intensity endurance exercise, and they are good for the muscles, metabolism, vascular function, as well as the heart. And when you have moderate intensity endurance exercise, like just what commonly people do, walking, then there is a benefit all through muscle, but not as much for the muscles as a high intensity endurance exercise. The resistance exercise helps only the muscles. They may not help metabolism much. They may not help the heart much, but vascular function is improved. So what exercise you do, or a combination of exercise, whether you do some endurance and some muscle gym type of activity, all that will help you in the goal that you're trying to achieve. But exercise you must. That is very important. Check your blood pressure, and checking the blood pressure is very important to keep your blood pressure normal. Now, commonly I see patients coming and telling me, my doctor told me at this age 140 or 150 is okay. It's not true anymore. The normal blood pressure is 120/80, and we have to keep the blood pressure as low as possible, because remember, the blood circulates through every organ in the body, right from the head to the toe. And whether it is the brain, whether it is the eyes, whether it is the heart, whether it is the kidney, every organ is served by the cardiovascular system, and the pressure affects each and every cell in the body. So it's important to keep it normal. The higher the pressure, the particular organ, what we call target organ, is exposed to a higher pressure, and this induces target organ damage. So you can have patients going in for stroke if the pressure is high. You can have memory, cognitive problems when the pressure is not kept maintained low. That is, people losing memory for names and other things. It's very important to keep the pressures normal. And you must remember that even a pressure about 90, 95 is still normal. Maybe a little too low, but it's better to have it above 100, 110. So people come and say, my BP is only 110/60, so I have stopped the medicines. When you give the medicines, remember that the blood pressure will come to normal. It doesn't mean you have to stop the medicine, because the disease process that has caused the hypertension is present in the person, and that has to be controlled at all time. When we give the medicines, the pressure becomes normal. Doesn't mean that it goes away. It is there. I give a small example to all my patients. I tell them, you take a bucket of water, fill it up, and put a hole with a nail or something. So what do you see? Promptly the answer is, yes, the water starts leaking through that. Then I tell them, okay, then you put a finger on that hole. Now the water has stopped. Does it mean that there is no hole? You say, yeah, no, the hole is there because I put my finger, it has stopped. The same thing with medicines. When we give medicines, the blood pressure becomes normal. Doesn't mean the blood pressure is gone. The blood pressure is there. It's only because of your lifestyle measures and the medicine, it is there. So even if your blood pressure is normal, medicine has to be continued, lifestyle measures have to be continued, and that's very, very important. Remember, blood pressure affects up to 30 to 40% of individuals. Even among this crowd here, if you take the blood pressure of 100 of you, at least 16 of you will be having high blood pressure. Guaranteed, because that is the study. Okay? So today itself, go and check your blood pressure. And remember, 120/80 is the normal blood pressure. Okay? Even blood pressures up to 139 is known as high normal. It's not normal, high normal. And the moment if it's 140 and above, it is known as stage 1, more than 160, stage 2, and more than 180, you are at risk of a event. Now, diabetes is another thing. It caused 2 to 3 times increased risk of heart disease, and 30% of coronary stents were implanted about 15 years ago. And even today, it is one of the commonest cause of heart attack, so more than 300,000, and 60% chance of dying from heart disease moment you are diagnosed as a diabetes. Now, why are these things important? Because these things, the blood pressure, diabetes, all these things are important for the aging. If you have these diseases, that person, the heart ages faster because hypertrophy. So high blood pressure means that the ventricle has to pump against the pressure. Through the valve, aortic valve, it has to pump against that pressure. Then only it can cross the valve and go there. So if your blood pressure is only 110/70, the heart has to do less work. The muscles do not go into hypertrophy. On the other hand, if the blood pressure above is 150/90, it means it has to work more. So that is what is important. So this can cause more of hypertrophy. And over a period of time, you do the echo and you see most patients will have grade 1 LV diastolic dysfunction. Most patients. You look at any echo report. And most patients will have that because there is a gradual increase of the myocardial fibroblasts which has caused this diastolic dysfunction. And this is because of a complacency, not only among patients, but also among doctors. It's okay, your blood pressure is a little high, doesn't matter. No, you have to reduce it. And of course, don't bring it very low, because below 100 or 90, there is again a U curve where the cardiac events can increase. So keep it at a reasonable level. What I would say is around 110/70, all that is very good. Then of course, cholesterol. Cholesterol is a very important thing. Among the cholesterol, all of you know very well that there are different forms of cholesterol, and the worst form of cholesterol is LDL cholesterol. LDL cholesterol. Let's switch off this one. Worst form of cholesterol is LDL cholesterol, and there is what is known as non-HDL cholesterol. Now, what is that? You have total cholesterol, which is the entire cholesterol pool, and then you have got LDL cholesterol, and you have got HDL cholesterol. HDL cholesterol is the good cholesterol. So from total cholesterol, you subtract HDL cholesterol, you get non-HDL cholesterol. Non-HDL cholesterol will contain all the components like LDL, VLDL, IDL, and all that. And these are the harmful things. So out of the LDL cholesterol, the non-HDL cholesterol should be kept below 130, and the LDL cholesterol should be kept below 100. Now, recent studies have shown that in persons with high cardiovascular disease risk factors, like for example, let us say there is a person who is a diabetic, hypertension, and his family history is very bad. Family history is very bad means if you have a male member in your family who has had a heart attack at an age less than 55 years age, that means you stand to a risk of cardiovascular disease. So if your father had a heart attack at 54, you also stand. So that is a risk factor, major risk factor, independent risk factor, mind you. Similarly, if a woman has a heart attack at the age below 65, all members in a family are also at risk. So if supposing somebody has such a risk factor, that is a genetic risk factor, plus diabetes, hypertension, they are called high-risk individuals. In these high-risk individuals, the LDL today level recommended today is 40. Not 100, not 70, 40, 40. So we have to bring the LDL level below 40. You have to bring the non-HDL level below 70. In these people, they are the high risk because they are at risk of cardiovascular disease at any time. So remember that when you go into your practice. So these are all old slides taken from 97. That here itself you can see the significant mortality when a person has high LDL cholesterol. Now this is a very important slide. This is an Indian diabetologist from Pune and his friend John Yudkin from Canada. See the BMI, this is regarding obesity, okay? The BMI of both these people are 22.3. Yajnik also 22.3, John also 22.3. But then when you do a PET scan, and the PET scan will identify what is the lipid pool, what is the thing. You see, the John has got only 9.1% of fat, 9.1% of fat, whereas Yajnik has got 21.2. So the BMI is same, number is same, 22.3. But our Indian friend has got 21.2% fat, more than the other gentleman. So this is to indicate the South Asian type of phenotype. We inherently, maybe because of our diet, because of our lineage, because of our agrarian type of population that we have more carbohydrates, more sugar. So it's all important for us to understand that in our diet, probably we are consuming more of calorie-dense, calorie-rich thing. Madam had given a slide, CR mimetics or something, a very nice slide. So it's important to see that these things are, the calorie part of it is counted. C for calorie, C for count. Keep counting it. And remember, every morsel of food, today I had nice samosa, thank you very much for that. But the amount of calorie is very high. So my good friend Narayan Swami said, here the samosa is very good. But he didn't eat, So anyway, so calorie counting is very important. Okay. I'm coming to the last slide almost, and most of the other things regarding diet and other things has already been covered. So I don't think I need to repeat that. Vegetables are very good. Yoga, wonderful for the heart. And these are some yoga asanas which are, you can get it from any website or a yoga instructor. Pranayama, Setubandhasana, Bhujangasana, Pavanakasana. I don't do anything. The only thing I used to do is pranayama and my push-ups. But better to do all these things, particularly standing forward and bending uttasana is all very good. So if you are able to learn and practice these things, they are very good for a healthy heart and to prevent aging. So I think I will stop with this, with the thing that wisdom lies not in the knowledge, but in the amount of its application. So just knowing all these things, or all the talks which we heard earlier, is not that important, but apply it in our life to prevent cardiac aging. That's what is important. So thank you very much for your patience. If there's any questions, I'll ask.
So on behalf of everyone, I want to say how much we appreciated this session and thank you for such a truly illuminating discussion, sir. And the session is open for discussion. If you have any doubts, you can clear it. In the online, you can post it in the chat or you can also ask it in the group.
Sir, very good morning. I'm Dr. Hemalata, Assistant Professor of Biochemistry. Very nice presentation. Thank you so much, sir. I have a doubt. My mother, who is 65 years old, post-angioplasty done. And she stayed...
had angioplasty?
Yes, sir.
So you are at risk?
No, I'm not talking about that. I've started to take care of myself for 3 years.
That's what I said, you have to take care of it.
Yes. I'm very confident about that.
Not only you.
Yes,
not
sir.
Only
my
you,
children also.
your siblings.
Yes, sir.
Your
Sure.
children may be two.
I'm the
yeah,
only
but your
daughter, so...
siblings. Your brothers, sisters.
I'm the only sibling. I'm the only person.
Okay.
My family. So my doubt is, so throughout the session yesterday as well as today, we have been concentrating about on the weight bearing exercises, all those things, and it is never too late. Even you can start now, all those things. So my mother is doing what the cardiologist advised is, not only my mother's friends in the apartment, all youngie parties are there in the group. So what they do is, they do only 40 minutes of walking, a brisk walk, evening times. But my doubt is, but when I touch the biceps or triceps, it is very flabby. And their rectors, everything, it is not that much strong also. Should they do weightlifting and all those things? Is it mandatory? And if at all, if they have to do, how many kgs they have to put? Not only my mother, sir, it is also in young generations. If you see my students, as well as many other students I see, they are taking lot of whey proteins. They want to have that macho look and big muscles. And they wear sleeveless shirts and all those things. Now it has become a trend. And they are lifting some 50 kgs. The boy is only 65 kgs, but he is lifting 50, 60 kgs. So that has become very popular nowadays. I'm not sure why, what is the purpose, how many kgs we have to lift? Is it mandatory to do for old age, high risk patient and for also youngsters? Do they have to do?
Sarcopenia, something which was mentioned. So sarcopenia is loss of muscle mass, muscle fibers as you age. And that is one of the things. That sarcopenia happens also in the cardiac myocyte. That is what the senescence and all things. So it is important to maintain a minimum amount of muscle bulk. I showed one chart where the endurance exercise. And endurance mixed exercise, and then weightlifting. If you notice, the weightlifting is the one which improves the muscle bulk, not the other things. So by doing weightlifting, you are maintaining a normal amount of muscle bulk. You prevent sarcopenia.
Yes, sir.
So it's not necessary you have to lift 50 kgs. Even small mass, like for example, I tell my people, if you don't have weights at home, just take 2 bottles, fill it up with water. A 1 liter bottle is 1 kilogram.
Yes, sir.
Even that much, if you're doing 10, 15 times, you can have muscle. Muscle bulk is important. Reason, if you are a diabetic, the muscle is the furnace which burns the glucose. So if you have muscle bulk and you are doing the walking, what you're mentioning, the more muscle activity is there, more glucose is burned, the better the sugar is controlled. And not only that, if you are walking for 40 minutes and more, why that 40 minutes is coming? Because the recommendation for exercise is 160 minutes of walking a week. So if you're walking 40 minutes 4 days a week, 4 into 40 is 160. You have to fulfill the criteria.
Yes, sir.
If you cannot walk every day, you do 90 minutes of endurance exercise in the weekend, 90 minutes. So that is why these people do that cycling, they go to Mahabalipuram back because they get that 90 minutes clocking. So the reason is you have to go into that 40 minutes. Just walking, there are some people who say, I do 10,000 steps. You would have heard that, many of you.
Yes, sir. It is very famous
Some of
nowadays.
you have digital watches. You will be thinking you are doing very good. No, you are not doing good. Reason is, the 10,000 steps is counted from the morning they get up to go to the toilet. Every step is counted there, and they say that that is not exercise. Exercise means you have to continuously do the exercise. Once you start walking, you don't stop. You continuously do. That is endurance. The meaning of endurance is continuously doing. It doesn't mean I walk from here to this block to the engineering college. So 100 meters, then again I walk back 100 meters. That's not exercise. You have to continuously walk. So that is why the 40 minutes what you or your mother is doing.
No, my mother's.
Okay, it's good for her. The other point you mentioned is she is flabby. So that requires diet control.
Yes.
So you have to look at your calories and other things.
Okay.
You have to cut short on calories and all that. Okay?
Along
And
with 1 or 2
one of
kgs.
our important thing as South Indians, I'm also a South Indian, we are in the habit of eating rice. You go to any hotel in the afternoon time, you won't get dosha and all this. Only meals ready, sir.
Yes.
So it's a meal time. Everybody eats meals, rice, and when you eat rice, there is no account, because the first thing is rice and sambar. The second thing is rice and rasam, and then comes the more. So you do not know the amount you are consuming. Whereas if you are taking idli or dosa, I have taken 2 idlis or 3 idlis, you can keep account. But when the person is eating rice has got the highest glycemic index. I think you will all be knowing
Yes,
that.
sir.
What a glycemic index means.
Yes, sir.
The capacity to increase the glucose. So rice has got high glycemic index. You take meals, there's no count on how much rice you take. So those are the things you have to look at. Cereals, you have to be very careful.
Yes, sir.
The madam was telling about whole grains. That is the best thing. If you take pulka, that is dry chapatis or something, cooked on a tawa and hot burner, the best.
Yes,
If we want to take something. Better to avoid the cereals. But I think it's difficult for us all to give up cereals. Okay?
Yes, sir.
Right. Have I answered your questions?
Yes, sir. So 1 or 2 kgs lifting is okay for her.
Yeah.
And
So
for anybody,
weightlifting is good, particularly old people. Yeah, it is recommended.
that weight is
Yeah,
okay.
because walking alone may not improve the muscles, because walking is a sort of an isotonic exercise. So you need something which is, which will help the muscle bulk.
Yes,
Okay?
Yes. Thank you so much, sir.
Thank you.
Any more doubts? Any more doubts online in the online session chats? No. Huh? Yeah.
Thank you, Dr. Joy. It was a very enlightening session. Thank you so much.
Now we are coming to the end of the session. I call upon Dr. Anandi ma'am and Dr. Guripavan sir to felicitate the speaker and the chairperson.
Aging is a natural biological process, but how it shows up on our skin is shaped by many factors, right from our internal physiology to the kind of environment we live in and also the kind of lifestyle we lead. And luckily for us, science hasn't been sitting quietly while time moved forward. Today, a lot of advances in clinical cosmetology is helping us to understand how medicine, dermatology, and aesthetic science can work together to support healthy and graceful aging. So our next session takes us right into the fascinating world where science meets skin and biology meets beauty. Let's explore how modern research is helping us age not just longer but better as Dr. Divya Vijayaraghavan ma'am shares her insights in this session. To introduce the chairperson of the event, I now call upon Ms. Kalpana to the dais.
A very good afternoon, and thank you one and all for joining us today for this wonderful session. It's my privilege to introduce the chairperson, Dr. Shantini Gopalakrishnan ma'am, professor in the Department of Biochemistry, Chettinad Hospital and Research Institute. Ma'am has completed her MBBS in Government Medical College, Kannur, and MD Biochemistry from Chettinad Academy of Research and Education in 2015, DNB Biochemistry in 2022, and PhD in 2025. Ma'am has 13 years of overall teaching experience in biochemistry and is actively involved in research in the field of diabetes and genetics and has received several awards. She has guided 7 PhD students and numerous national and international publications in reputed industry journals. She is a member of Indian Medical Association and Association of Medical Biochemists of India. Ma'am has published 2 copyrights and also authorized a book titled Clinical Case Scenario for first year MBBS students in biochemistry. Ma'am has also completed several academic certifications including NABL Internal Audit Training course ISO 15189-2012. We are honored to you as a moderator for this wonderful session, ma'am. Over to you, ma'am.
Good afternoon, everybody. Thank you for the introduction. First of all, I'd like to thank Dr. Ananthi ma'am for inviting me for chairing this session. So my work here is to introduce our eminent next speaker. She's a dermatologist, Dr. K.R. Divya Vijayaraghavan. Ma'am is a consultant dermatologist and cosmetologist in Radiance Clinics, Mogaper, Chennai, and also Billroth Hospitals, Chennai. She is a consultant dermatologist and cosmetologist with over 18 years of clinical experience. She completed her MBBS from Government Stanley Medical College and PG Diploma in Dermatology from Madras Medical College, followed by IADVL Fellowship in Cosmetology and Fellowship in Lasers. She is actively involved in clinical practice, academics, and aesthetic dermatology. She has her specialized areas of interest in dermatosurgery and hair transplantation. Also an Ayush Ministry certified yoga teacher and fitness enthusiast. So I think all the female audience will be eagerly waiting to hear what Madam has to say. So please welcome ma'am.
Check. கொஞ்சம் லிஃப்ட் பண்ணுறீங்களா?
Check. Vanakkam. A very interesting session was there. Great insights about cardiac senescence and interventions and what all you have to do to overcome graceful aging. Thanks to sir, the slides were too good and very informative. Today, we are here to talk about something which every human experiences in their lifetime. But science is working constantly to explore what is happening, how can we understand better aging. So here I would like to say a few words about skin, because skin is the first ever visible biological marker of aging. Myself, Dr. Divya Vijayaraghavan, thank you ma'am, thank you for the intro, thank you so much. So aging is that one condition everyone has to go through in their life. But our only concern is to age well or age gracefully. Unfortunately, there's no vaccine for this specific condition, though it has 100% prevalence. But the good news is, dermatology has become very good in slowing down aging. Is it changed? So we have to understand aging. I think most of you would understand this guy. He's a Singaporean. He's a recent sensation in social media. This guy, he is actually 60 years, but he doesn't even look close to even 60. Can you even imagine he's 60? No, it is very, very difficult. Could be his genetics, could be his lifestyle, could be his activity, or even dermatological treatments that he may have been taking. No one knows. But there are a lot of factors that influence aging. So we have to understand aging, because aging is inevitable. But looking at your, looking older than your age is definitely optional. I would like to share a small story about a walk-in patient a few days back in my clinic. She just walked in and she never said, she looked at a mirror in the side wall and she said she never said, "Doctor, I'm aging." She never said, "Doctor, I have wrinkles, I want treatment for this." What she said is, "Doctor, I am not looking myself." She said, "Enoda face enna madriye illa, vera madri irukku." Just that, imagine the situation. She started saying that I look older, I look dull, I look tired, I have wrinkles, all those. She was literally mentioning that there is mismatch between what she is from the inside and what is there seen in the reflection. That is where dermatology has its major role. Because we have multiple factors in aging, intrinsic and extrinsic factors. That means we have those components that you cannot prevent and those components you have some role to prevent it. Now this guy, Brian Johnson, this man spends almost $2 million on anti-aging treatments. Like, you cannot even imagine how much he's taking. He's taking more than 100 pills every day to combat this aging. He's literally working against aging. So he has got so much belief in our science that he is working towards, literally against aging, like reversing aging. Maybe he looks successful in what he's trying to, but we are trying to understand it better. Aging, this is a universal biological process. So we have to understand it better so that we can slow down the process. Because aging has an 100% incidence doesn't mean that you can stop, because the patients or whoever it may be who doesn't want to age don't want to stop aging. They want to slow down the process. They want to take control of how they appear. That's what we are trying to understand here. So we have multiple factors for aging. We have two types of aging, intrinsic and extrinsic, depending on the factor which influences aging. With intrinsic aging, this is chronological, genetics, hormonal changes, natural collagen loss, reduced cell turnover, and extrinsic aging, the major factor being ultraviolet radiation. Like, of the extrinsic factors, UV exposure gets 80% of its credit for photo damage and photo aging. Other factors include definitely our lifestyle habits, pollution, smoking, environmental exposure, everything. So think of intrinsic aging as your birthday candle and extrinsic aging as the number of intrinsic aging as your birthday cake and the extrinsic aging as like the number of candles you add onto it. So it means we do have some influence in controlling that. Coming to the physiology of aging, there is a progressive decline in structural and functional integrity of the skin. So molecular level, you can see there is telomere shortening, DNA damage accumulation, mitochondrial dysfunction, reactive oxygen species, and senescence associated secretory phenotype. Everything almost covered in the previous session itself. Like there is severe oxidative stress because of the senescence. There is surrounding inflammation that is trying to degrade its own tissues. So here, the senescent cells just don't stop dividing. They become inflammatory neighbors, trying to degrade their surrounding tissues. So they secrete, once they become older, they stay there and they stimulate cytokines, they cause a small inflammation and matrix metalloproteinase, which further degrades its surrounding collagen. So ideally there is this kind of a scenario where you are losing the existing collagen and we also fail to produce more new collagen. So there is a structural deformity because of that. So the skin loses its elasticity, its integrity, and ideally it will keep on happening where you will end up in some kind of a situation where the skin becomes irreparably damaged. And that's where you have to take up certain treatments or medications or lifestyle habits, whatever you say, that could slow down this natural biological process. So these senescent fibroblasts also activate or induce cytokine formation and matrix metalloproteinase in the aging skin. So aging isn't a passive decline, it is biologically active remodeling. Now here, deep down into the cellular level, intrinsic aging, the molecular mechanisms are basically cellular senescence giving rise to oxidative stress, matrix metalloproteinase activation, and extrinsic factors like ultraviolet radiation activates reactive oxygen species. It also stimulates epigenin 1, nuclear factor kappa B activation, which suppresses TGF beta signaling, reducing collagen production. Simultaneously, as we had already said, MMPs degrade the surrounding collagen. This collagen degradation definitely is more than neocollagen synthesis. So because of this mismatch, we lose the old collagen and fail to make new collagen. There is an architectural instability, I would say. This structural imbalance gives rise to more wrinkles. Like initially it happens as like fine lines, which you get deeper by activating the muscles because of our facial expressions or activating the muscles. But then it goes on and on and on, gives rise to deeper static wrinkles. Now histopathological changes, epidermally, you see epidermal thinning, flat and dermoepidermal junction. So in a youth, if you're taking a skin histopathology, you could see the dermoepidermal junction as a mountain peak, whereas in an aged skin, you could see the dermoepidermal junction is like pretty flat. Number NH mari flat arkum. Of course, sometimes konju gundu kuri adala, open pores, scars, everything will be there. There is reduced keratinocyte turnover, reduced melanocyte density, and dermal changes include reduced collagen bundles, reduced fibroblast activity, reduced vascularity too. So skin basically loses its shock absorbers. So there is mechanical instability, and it makes the skin more fragile and delay in repair is there. This is a very typical photo-aged skin picture. We call it solar elastosis. there is disorganized collagen, abnormal elastin deposition, dilated blood vessels. Here you see the wrinkles are very deeper, but the skin doesn't look atrophic because the deranged or damaged elastotic material gets deposited in the skin itself. So it gives a thicker look, and there is an yellowish tinge because of the thickness of the dermis and epidermis, and there is dilatation of blood vessels, sometimes telangiectasia, sometimes pigmented spots, all those are seen. So unlike, see, what we will think, if the skin becomes atrophic and thin, it will get repaired, so it will get damaged easily. But here the skin is thicker, but it is definitely weaker because it doesn't go it fails to recoil. So though it looks tougher, it definitely behaves confused. That's why we insist on using photo protection repeatedly as part of your skincare routine. And this is yet another reason why older people always say, like, even with a little trauma, they end up having ecchymosis or skin breakages. But when the trauma happens, the healing takes a lot of time because there is degradation of collagen, elastin is very less, and there is definitely an undergoing very minimal inflammation. So clinical signs, facial aging is definitely multi-layered. It involves skin, fat, ligament, even sometimes bones. That's why you get like that sunken look. Even bone resorption is there. So facial aging starts with fine wrinkles and goes on to give a deeper static wrinkles, pigmented dyschromia, laxity, volume loss, enlarged pores, surface, So because of this volume loss and deeper involvement of the deeper structures, we always say, once you have this, when you present with this signs of aging, a surface cream or just some kind of an application may not be sufficient to combat with this deeper damage. That's where you have to go in for structural procedures like fillers, Botox, or other procedures that will support the skin structures from the deep. Yes, the structural changes that have happened beyond skin are fat pad atrophy, volume loss, ligament laxity, bone resorption, facial contour changes. Why doctors, specifically dermatologists, insist on taking anti-aging measures pretty far ahead of when actually aging starts? Aging does not start right from after 30 or 40 as a mark. It starts well ahead of, like, literally decades before your third or fourth decade. That's why we insist on taking following a skincare routine well before, so that you slow down the process. It's not an escape, it is slowing down the process, so the aging happens pretty well, so that we have a greater look when we are aging. Collagen, because every year 1% of collagen is lost. So by the age of 40 or 50, most of your collagen has packed its bag already. We do have certain assessment tools to assess aging. Why do we have to assess? So that we can decide on what kind of a management you do require. We have Glago photoaging scale, Fitzpatrick wrinkle scale, VCI imaging to assess the aging severity, so that we can decide about what are we going to do. To start with, topical. What is the most prescribed? Retinoids. When someone is advising you to go in for some kind of serums, some anti-aging serum, vitamin C serum, vitamin A, don't go blindly. Just start with skincare routine, even when you're young, like in your teens also. Start with a moisturizer, a sunscreen. Because still, again insisting that ultraviolet exposure causes severe photo damage and photo aging. So we do insist on photo protection every single day, which has a greater impact in anti-aging. Another thing is retinoid. Retinoid actually is the gold standard in anti-aging treatments because it normalizes keratinization, It improves collagen synthesis. It definitely decreases MMP activity. It tries to do a collagen remodeling every day whenever you apply. So anti-aging is the gold standard in, retinoid is the gold standard in anti-aging treatment. Apart from this, we have vitamin C, which is an antioxidant and collagen cofactor, niacinamide that helps in barrier repair. We have peptides, alpha hydroxy acids, beta hydroxy acids, natural moisturizing factors like ceramides, hyaluronic acids, but all these in combinations would work greater in anti-aging. Other interventional procedures can be used as a managing tool for aging. Of these, a very, very simple procedure is chemical peel. It is like, what is a chemical peel? We are applying so many creams, we are using vitamin C, sometimes we do use vitamin C in the form of tablets, vitamin E is being used. So these are concentrated chemicals. இப்போ நம்ம ஒரு ointment apply பண்றோம் இல்லையா, a similar ingredient that is given in a higher concentration, so that it is applied onto your skin to enhance skin rejuvenation. But it is applied in a for a very short contact under observation by a dermatologist, so that we can assess how much concentration you need, how much contact time you need, and how and when we have to stop contact. So higher concentration topicals, to put it in simple words. A component like glycolic acid, salicylic acid, TCA, lactic acid, vitamin C, ferulic acid in combinations works greater. Basically, it improves pigmentation, it works better on your acne, it improves the skin texture, stimulates collagen. So chemical peels does work for superficial scars too. Chemical peels periodically used definitely gives a greater glow, greater skin texture, and a little bit of skin tightening too. Yet another simple procedure, but not given so much of emphasis, is microneedling. Very beautiful procedure. It can be done under a dermatologist observation and sometimes can be done as at-home procedure too. It is basically multiple layers of needles that will prick your skin, causes micropores, and that helps in better absorption, or it acts as a transdermal delivery system. So it helps in better absorption of the specific drug or a skincare regimen you are using. It also causes controlled dermal injury that helps in greater collagen induction. Though the visible scars can be completely erased with multiple sessions of microneedling. Microneedling can also be done with energy like radio frequency. So the needles will carry some kind of an energy so that it goes deeper inside and causes better collagen induction. Apart from this, wrinkle reduction, skin texture improvement, skin tightening are the benefits of microneedling. So when do you want this structural intervention or injectables? Most of us do know about Botox or fillers, we would have heard it from somewhere. Because these modern anti-aging interventions focuses on structural intervention, because they just don't erase or soften the wrinkle, it acts deeper inside so that the structure, what is lost, can be restored. Of this, the first and foremost is Botox, or botulinum toxin. Botulinum toxin is basically, how does a wrinkle appear? A wrinkle appears because of the overaction of the muscles of your face. So while there is expressions, the muscles are overacting, or even in normal action, facial expressions, you do get wrinkles when you're aging because of the loss of elasticity and collagen in your skin. So botulinum toxin in controlled or lower doses temporarily paralyzes those facial muscles. And then the muscles relax, and even during expression, you do not get wrinkles, and the process is definitely temporary. It also helps in preventing static wrinkles from being appearing. Another very good injectable is filler. Basically, these are combinations of hyaluronic acid fillers. These hyaluronic acids are chemically inert. They are very stable and they don't react to your skin. These are in gel forms or sometimes very lighter solution forms that are injected into your deeper structure under your skin, so that the volume which is lost will get reverted back to its original shape. But these are also temporary, but unlike Botox, fillers are will have a very long shelf life. Because these are very, very, very safe, and it also absorbs furthermore water after it is being injected. It will give you a greater look. Apart from volume restoration, it will also give you a glow. That's why fillers are most sought procedures in cosmetology. There is volume restoration, there is beautiful structural lift, there is glow, and minimal wrinkles are being erased with filler injection. We do have these smaller skin boosters also, we call these days, that are being most sought because it will give you a skin lightening effect and textural effect too. Others like biosimulators, polylactic acid, calcium hydroxyapatite will also cause collagen induction. It will also give you instant support to your skin from the inside. Apart from injectables, we have energy-based devices which works beautifully on dermal remodeling. It helps in pigment erasure, it helps in collagen induction. Fractional CO2 is ideally a laser resurfacing procedure which causes dermal remodeling, so that you get rid of those very smooth wrinkles, improves the texture, and you can get rid of pigmented spots too. Radio frequency micro needling, that I had already said, there is energy when the needles are pricking your skin. So it helps in greater collagen induction than simple micro needling. HIFU, it causes skin tightening. It is high intensity focused ultrasound. It causes skin tightening and the mass layer tightening also. You get rid of double chin. Sometimes people lose weight and they will have loose saggy skin all over the body and face. Here HIFU plays a greater role. Here there is controlled thermal injury that triggers a wound healing cascade and helps in neocollagenosis. So what kind of a treatment or therapy do I have to select if it is for me? Then when do I have to do? So skincare routine start well ahead of aging, and when it comes to, if you see simple signs of aging, we have to consult a dermatologist and select the therapy what you would need. To start with, it is topicals, and you can also choose with injectables or lasers or Botox or fillers, whatever is needed, but a combination therapy always works great. Sometimes aging may not be just aging. It could be a signal of underlying systemic disease. So we have to evaluate when the patient comes, apart from history, apart from the symptoms, when did it appear, and examining, you have to come to an idea if it is really just a normal aging, or is there a hidden sign that is not being really revealed. This aging sign could be a simple marker of an underlying disease. So we have to evaluate them before jumping into a conclusion of going in for a filler or Botox. So it could be a hormonal dysfunction like thyroid, nutritional deficiency, it could be a chronic illness, simply could be chronic stress too. The chronic stress can increase cortisol levels, that can, higher cortisol levels for a prolonged time could break down your collagen. Who knows, it could be chronic stress. So we have to identify what is the hidden sign. That's why evaluation is very, very, very important. Now, apart from these injectables, laser machines, all those, we are going into future of anti-aging where we focus more on regenerative dermatology. We are trying to use stem cells, we are trying to give PRP therapy, which is platelet-rich plasma, where you extract the platelet concentrate from your own blood and then inject it onto your skin. That will help in repair and regeneration, better collagen induction. It helps in hair growth. It helps in improving the texture of your skin. It helps in giving you a greater glow and skin tightening. And exosomes are those newer trend in dermatology. We are focusing more, and there are more studies in exosomes these days. These are nanovesicular substances that are extracted from the stem cells that will significantly target a specific cell. So it is transferred from one cell to the target cell. It improves the cell-to-cell combination. It helps work in that specific site. That's why there are more research and more studies on exosomes these days. Exosomes are extracted from your muscle cells, mesenchymal cells, from your platelets, even milk, plant and animal derived exosomes are also there. So the future might not be just slowing down in aging, it can also be going into partially reversing of aging. That's where we are now these days. Sir has beautifully said about yoga in aging. It is not just skin, it is not just in your cardiac, overall health, yoga helps a lot. So when it comes to preventive dermatology, as it is already mentioned multiple times, go for skincare routine, go for photoprotection, which is very, very, very important. Apart from these, supplementing with antioxidants in the form of fruits or taking up pills, healthy lifestyle, make yourself pretty active. Have a focus on the nutrition, what you're giving to your body. So when we say all these lifestyle habits, everyone will think of going to some form of exercise, going to gym, taking up a lot of weights and focusing on nutrition. Everybody will forget about sleep. Sleep is very, very important because regeneration, repair happens only during sleep. Focus on sleep. It doesn't mean that you can be awake all night and you can sleep for 10 hours a day. Don't change your circadian rhythm. Your circadian rhythm is very, very important. That's how your body is tuned to. So have a good sleep and then focus on hydration. These are simpler things we usually neglect. So healthier lifestyle always is a combination of these. So one more most powerful anti-aging intervention that helps in managing stress and also keeping up your lifestyle better is yoga. I think I am one of the best persons to talk about yoga. I follow yoga every day, every single day, regularly. It's my passion also. Of course, this is me. Because yoga is a very traditional technique and we do lack so much of literature in yoga. But now it is booming up because people are trying to understand yoga as a greater tool, as a better lifestyle technique that keeps you healthy. Sarah's posted many postures, like one, if you are doubtful what to do, just focus on Surya Namaskar. Surya Namaskar is like a greater combination of those 12 asanas that only that is enough to maintain an, an ideal workout session. So Surya Namaskar is a best combo pack. So beyond creams and laser, focus on your inner lifestyle. It helps in stress reduction so that there is lesser cortisol, better collagen induction, and you don't lose your collagen faster. Of course you do lose, but you will be losing a little lesser or slower. There is improved circulation so that the nutrient supply is better. There is greater lymphatic drainage so that the toxin clearance is better, because in traditional methods, our alternative science and Ayurveda, toxin clearance plays a major role because they believe that disease happens because of the imbalance of 3 doshas and toxin accumulation. So better lymphatic drainage, better toxin removal. Improves sleep quality and also hormonal balance. So when we talk about yoga in specific, people do go in for yoga as a therapy. It is not a therapy. So when you have joint pain, when you have back pain, when you end up having uncontrolled diabetes or aging, then you go for yoga. No, it is not just an erasure. It should be implemented well before, and it should become your lifestyle, so that it is a greater lifestyle rather than a treatment. It helps healthier skin aging from the inside. Okay? Because aging is inevitable, we have to accept and understand how aging happens. So premature aging is definitely preventable. So though chronological aging, you cannot stop it, but you can slow down the effects how you see your natural look. So we don't intervene, as a dermatologist, we don't intervene in aging therapies, anti-aging therapies. As like if someone in their 50s come to us to look younger, we cannot just reverse the aging. We actually don't aim to make them look 25, definitely not. But we will aim to a healthier natural look. So you should look better for your age. That's our aim. So aging is not only structural, it is cellular, it is hormonal also. And prevention is powerful, regeneration is very, very possible. Ethics is essential here. Because when someone just walks in their 20s asking for fillers just to look plumpier, just to look with the international beauty standards, as a dermatologist, I would definitely say no. I don't want you to look like Aishwarya Rai. I want you to have your better version. That's what we aim for. So you have to look better than what you would actually be without any healthier habits or aged look. That is what is our aim. So don't have over expectation. Don't ask for overdoing the procedures, because it will definitely end up in a wrong appearance. Someone beautifully said, beautiful young people are accidents of nature, but beautiful old people are works of art. We dermatologists own the saying, because we cannot stop chronological aging, but we can modulate biological aging. Our goal is not to reverse age, but to optimize tissue response to time. So how would I define aging? It's not to make people look way younger than their age, not to make them look like teenagers or in their 20s, but to make them look like the better version of their current age. Because time moves forward, so does dermatology. Dermatology may not stop time, but it certainly helps people face it with confidence. So with that note, I'm honored to have such a greater session in front of the scientific gathering. Thank you, Anandi ma'am. Thank you so much. Thank you, Hema ma'am, for giving me this opportunity. If this 40-minute session is not enough for you, we are giving such dermatology insights in shorter video forms in my YouTube channel. If time permits, feel free to drop in. I'd be happy to appreciate that time. Thank you so much.
Thank you so much, ma'am. That was one amazing session we just witnessed. Every time we open YouTube and Instagram, we have so many influencers trying to review a lot of products, this and that. But now that we have a cosmetologist and a dermatologist with us today, I think it will be a sin if I let you go without asking you to review a few of these Gen Z using products. So on a scale of 1 to 10, I'll tell you few of the products. On a scale of 1 to 10, please rate them. Yes, ma'am. 1 being the worst and 10 being like absolutely wow.
Okay.
So the first one is Ethiglow face wash.
Definitely depend on the skin type, but overall I would say 5.
Okay. Ice rollers that people use during their night routine.
Ice roller, yeah, 4. Jade roller or ice roller.
Okay. Then gua sha and jade roller.
3.
Okay. What about snail mucin, ma'am?
Snail mucin, no. 2. No, that's not my favorite.
The LED face mask.
Yes, it does work. It is a low light laser therapy. It works better. 7.
Okay. And one important question, ma'am. Body washes or the normal soap?
Body wash.
Oh, thank you, ma'am. That was really so sweet of you, ma'am. So the
rice water suits some people, but nariya perku it triggers acne. So I would put it as for dry skin or combination skin, it is fine. Oily skin, no.
Okay. Thank you so much, ma'am, for that review. I think now we have review from a certified person. And the floor is now open for discussion, questions. Any questions anybody has? I thought this session will have so many questions. Come on.
Yes, aloe vera. See, if you're buying a preparation, the authenticity you have to check, sir. Otherwise, aloe vera is a moisturizer. It's a great moisturizer. That's all it is. It does not give glow to your skin or it erases pigmentation. That it's a moisturizer. Like coconut oil, it is a greater moisturizer. And some people tend to extract it directly from the plants and then apply it. I would say no, because you have other mucins and all that will tend to irritate your skin. If you are extracting it normally and wash it off and then apply it in a gel form, it is fine. Be safe. It's a good moisturizer. Collagen based creams, very good question, because people are chasing collagen like anything. Collagen is like a bigger molecule. Adu vandu cream forms la use பண்ணும்போது getting absorbed and then giving you collagen injection is not possible. So collagen as supplements, as pills, it works to some extent. இப்போ bone broth மாதிரி non-veg bone broth, adula it will help you a lot better. And interventional procedures like microneedling, lasers, definitely greater. As creams, face wash, it does not work. Skin whitening cream, best. ஒரே கான்ட்ரவர்ஷியாக இருக்கு. Skin whitening, no. So you can step up your pigmentation to 1 or 2 shades with many creams, which molecules இல்லை பேர்லாம் சொல்லக்கூடாது. Kojic acid, vitamin C. இல்லை சார், நம்ம இதில் we are using 2% to 4% வரைக்கும் சேஃபாக யூஸ் பண்ணலாம். டெஃபினெட்லி 10% க்ரீம்ஸ் எல்லாம் இருக்குது. கோஜிக் ஆசிட், விட்டமின் சி, ஹைலோரானிக் ஆசிட் காம்பினேஷன்ஸ், ஆல்ஃபா ஆர்பியூட்டின், AHA, BHA, it works well in combinations. Yeah, vitamin serum is universally used மாதிரி ஆயிடுச்சு. இப்போ everybody is using. 10 years old is asking vitamin C serum use பண்ணலாமான்னு. I don't understand where is the need. But vitamin C is an antioxidant, anti-inflammatory use பண்ணலாம். It helps in lowering the inflammatory process. ஒரு inflammation இருந்துச்சுன்னா நல்லா ஹெல்ப் பண்ணும். Sometimes dry skin combination skinல நல்லா work ஆகும். Acne skinல it can trigger acne, so அது percentage பார்த்து யூஸ் பண்ணணும். Moreover, the ingredient is very important. L-ascorbic acid formல வந்து it is very potent, but along with that it is also a little bit irritant. So to start with, use from 2 to 5%. So skin adapt ஆனதுக்கப்புறம் 10 to 20% வரைக்கும் போகலாம். How much your skin accepts is important. ஏன் சீரம் ஃபார்மில் சொல்கிறோம் அப்படின்னா, better than cream and ointment formulations விட சீரமில் வந்து the ingredient is stable and the absorption is better, so it becomes more effective in serum forms.
Madam, one more question. இப்போ உங்களுக்கு வர patientsல whether male patients are more or female patients are more, because whenever I talk about this beauty products, see sir கேக்கும்போது எல்லாரும் they started to laugh and you know, but when it is pertaining to when ma'am fired the question, nobody question about it. யாருமே சிரிக்கல, because according to them, to the society, beauty standards எல்லாமே வந்து all these cosmetic, botox எல்லாமே it belongs to women now. Why we are biased ன்னு தெரியல எனக்கு. But உங்களோட எக்ஸ்பீரியன்ஸ்ல உங்க கிளினிக்ல மேல் பேஷண்ட்ஸ் ஜாஸ்தி வராங்களா, ஃபீமேல் பேஷண்ட்ஸ் ஜாஸ்தி வராங்களா?
அப்படி பொதுவா சொல்ல முடியாது. But it used to be more
statistically
than men முன்னாடி. ஆனா இப்போ கண்டிப்பா கிடையாது. Men are equally worried about their cosmetic appearance as well as using skin products. So it's kind of equally good.
Okay, thank you, madam. That's my question.
Sun protection films that we get, ma'am, SPF 20, 50, these two various things come. Can you just, I know it's always should be used based on a dermatologist's advice, but still can you just enlighten us on those numbers that what is the apt thing if, without going to a dermatologist, if you want to use a sun protection film, which number should we select for?
SPF 30 is like the least. ஆனால் SPF வந்து சன் ப்ரொடெக்ஷன் ஃபேக்டர், அது வந்து இன்க்ரீஸ் ஆக ஆக யூ ஹாவ் அ பெட்டர் ப்ரொடெக்ஷன். ஸோ டு ஸ்டார்ட் வித் 30 இஸ் ஐடியல் ஃபார் அவர் ரீஜன். ஆனால் இப்போ கொஞ்சம் நிறைய என்விரான்மெண்டல் சேஞ்சஸ் அண்ட் சன் எக்ஸ்போஷருமே நிறைய இருக்குன்றதுனால கோ ஃபார் 50. SPF 50 இஸ் லைக் ஐ கேன் அட்வைஸ் எனி ஒன். More than 50, 60, 70, even up to 80, you will have better sun protection, broader sun protection இருக்கும். But 100, 110 and all will not make a greater difference. So 50 is good.
Thank you.
Any other questions? Online question.
So good afternoon, ma'am. Ma'am, like even or 10 years before, we'll be using all traditional home-based skincare and all, like flowers. Now we are switching to other serums, moisturizers, sunscreen. So according to you, which is best? Shall we use that or which will give the best result, ma'am?
சரி, ஒரு எக்ஸாம்பிள் சொல்லுங்களேன்.
Before we'll used to use பெசன் ஃப்ளோர் கர்ட்லாம் வச்சு யூஸ் பண்ணுவோம். நவ் ஸ்விட்ச் இன்டு இப்போ நியாசினமைட், கோஜிக் ஆசிட், வைட்டமின் சி.
எக்ஸாம்பிள் அதுக்காக தான் கேட்டேன். ஏன்னா மோஸ்ட்லி எல்லாரும் கேட்குறது கடலை மாவு, பைத்த மாவு, ஆல் தோஸ். சி ஃபார் த என்விரான்மெண்டல் சேஞ்சஸ், ஃபார் த ஃபுட், ஓவரால் லைஃப் ஸ்டைல் எல்லாமே மாறிடுச்சு. ஓகே, ஸோ அந்த மாதிரி ஒரு சேஞ்சஸில் இருக்கும்போது நீங்கள் when you're going back to your traditional methods is good, but to some extent it is good. Because if I say go for traditional methods, they will definitely go think about turmeric, honey, potato, tomato, inji poondu ella potruvaanga. This does not work that way. Understand what you're using. இப்போ traditional methods na odane na veetla poitu kadala maavu poduven sonna okay, you will all accept it. If I say toothpaste vittu curry pottu veinga na panuvingla, you won't do it, and it is not smart also. Okay, so you can rely on some things like honestly milk and the palada, curd, all those can be used. Definitely don't rely on those traditional methods as a cure or as a like regular skincare method use பண்றது I won't advise. Because vitamin C இப்போ நான் supplement எடுக்கிறோன்னு வெச்சுக்கோங்களேன், I can say like 500 mg, 1000 mg per day helps a lot in your skin glow. But on the 1000 mg வேணும்னா நீங்க எவ்வளோ ஆரஞ்சு எடுக்கணும் தெரியுமா? You have to take 2.5 to 3 kgs. Is it possible? So we are taking a lot of things as convenience. அதே மாதிரி தான் convenience. Sun protection நீங்க எடுக்கிறீங்கன்னா a broad spectrum sunscreen ஒரு convenient formல யூஸ் பண்ணும்போது you will tend to stick on to it for quite a long time. But if I say ஒரு coconut oil, zinc oxide வாங்கி நீங்க ஒரு பேஸ்ட் பண்ணி அப்ளை பண்ணுவீங்கன்னா it is very very difficult. You cannot practically follow it. So adapt to the changes and then go follow fewer traditional methods. Like definitely இப்போ யோகா பற்றி பேசும்போது எல்லாருமே அக்செப்ட் பண்ணிக்கிறோம் because it is possible. ஆனால் யோகிக் டயட் ஃபாலோ பண்ணுங்க, சாத்விக் மெத்தட்ஸ் ஆஃப் டயட் ஃபாலோ பண்ணுங்க, and then do pranayama 1 hour every day. Now it is practically not possible in this fast world. So whatever goes well, அதை வந்து ஃபாலோ பண்ணலாம் வித் அண்டர்ஸ்டாண்டிங் ஆஃப் த நெகட்டிவ் ஆஸ்பெக்ட்ஸ், ப்ரோஸ் அண்ட் கான்ஸ் பார்த்து யூஸ் பண்ணுறது பெட்டர்.
ஒன் மோர் கொஸ்டின் மேம். ஸோ டேக்கிங் இன்டேக் ஒரு ஃப்ரூட்ஸ் அப்படி எடுக்கிறது குட்டா இல்லை ஒன்லி ஃபாலோயிங் ஸ்கின் கேர் இஸ் பெஸ்ட்டா? விச் இஸ்
நோ இது இட்ஸ் அ காம்பினேஷன். நீங்கள் என்ன தான் ஸ்கின் கேர் பண்ணாலும் if I have uncontrolled diabetes, if I don't follow any active lifestyle habits, proper nutrition follow பண்ணல, I have the hormonal imbalance, now you will end up spending more. You won't look the way you want to. Definitely it's a mix. And I also wanted to answer you, Dr. Hemlatha. நீங்க வந்து you were talking about strength training. And பசங்கெல்லாம் வந்து வே ப்ரோட்டீன் யூஸ் பண்ணுறாங்க, they are lifting a lot, they are trying to bulk up their muscles. See, in my opinion, I would say you can actually encourage them to go for workouts in the right methods. இப்போ strength training பண்ணுறாங்க, bulk பண்ணுறாங்க, protein focus பண்ணி யூஸ் பண்ணுறாங்க அப்படின்னா definitely go ahead. But some people want to bulk up artificially with steroids, சில stimulants யூஸ் பண்ணுறாங்கன்னா no. But strength training definitely is a must. And if a guy or a girl in their teenage or in their 20s is doing that, it is a welcome change. My opinion.
Yes, yeah, sure. Yeah. Okay, any other questions?
Ma'am, we have a question from an online participant. What is the role of tranexamic acid in anti-aging, especially melasma, which is commonly seen in old age group? Nowadays, we can see serum preparations based on TXA. Are they reliable to use?
I'm thinking that in the presentation பண்ணாம நேரா questions பண்ணிருக்கலாம். Yes, tranexamic acid is a milder skin lightening ingredient in the form of tablets, in the form of creams and injections. It works to combat this pigmentation, specifically melasma. What else it was? As an anti-aging, no. If uneven skin tone irukku, pigmentation spots because of aging abdina, it will work. But basically, it is an anti-aging ingredient.
Thank you so much, ma'am. I hope that clears their doubt. And skincare is not makeup. I think, thank you so much, Hema ma'am, for bringing that out. And thank you so much, Radha Krishnan sir, for setting an example to all the boys and men here. And with that said, I now call upon Dr. Hema Anandi ma'am, Dr. Pavan sir, and Dr. Hema ma'am to felicitate both our speaker and the moderator of the session.
To conclude, I am madam student as well as Shantini madam student, and அது வந்து ஒரு 20 வருஷம் முன்னாடி. இப்போ நான் தான் என்னமோ ப்ரொஃபஸர் மாதிரி இருக்கேன். மேடம் இஸ் ஸ்டில் லுக்கிங் லைக் a student. எங்கள் ஹெச்ஓடி HOD often used to say when we were doing MBBS, best way for anti-aging or healthy aging is காய் கனி பயிர் தயிர். இதை வந்து டெய்லியும் உணவில் உண்ணுங்க அப்படின்னுவார். ஆமாம், முருகானந்தம் சார். அதை இந்த எல்லாத்தையும் எடுத்து ஃபேஸில் இப்படி கண்ணில் போட்டுக்கிறதுக்கு பதிலாக அதை எடுத்து வாயில் போடுன்னுவார். Yeah, very true. Thank you so much. So we'll break for lunch. Lunch is it?
I know our stomach is rumbling because with all this back-to-back sessions, oranges, fruits, curd and all. So we'll break for lunch for 45 minutes. The same place, pathology lab in the 5th floor of the building. And kindly reassemble back at the earliest because we have another interesting session and the much awaited prize distribution. Those who have not got their food tokens, please come to the front desk and get your food tokens. All of you enjoy the meal. Thank you.
ஹலோ செக் செக்
இருந்து
செக் செக் வருதா? ஹலோ செக் செக். இந்த ஒரு ஆடியோ மட்டும் தானே வருது?
ஆமாம்.
நைஸ் எதுவும் வருது?
எதுவுமே இல்லை.
கரெக்டாக இருக்குது.
கரெக்டாக இருக்குது.
அந்த எஸ்டி மட்டும் தான் செக் பண்ணணும்.
எதில்?
எஸ்டி மட்டும் தான் நம்ம செக் பண்ணணும். எஸ்டி வேறு
இப்போ வருது இல்லை?
ம்.
அந்த கேபிளில் சொல்லுவாங்க வருதான்னு செக் பண்ணிடுவாங்க. இந்த கேபிளில் கழட்டி இந்த அங்கேயே கேமராவை அங்கேயே வச்சுக்கோங்க.
இப்போ வருதா பாருங்க.
ஆடியோ
கிளியராக இருக்கா? வீட்டில் இன்னொரு ஹெச்டிஎம்ஐ இருக்குது, அதை எடுத்துகிட்டு வந்துடுறேன் வரும்போது. எஸ்டி அவுட்டாங்க. கரெக்டாக இருக்குது தானே?
ஆடியோ கிளியராக
Check. I welcome you all back after an amazing lunch. We'll resume with our scientific session of the day. If there's one organ that truly shapes how we experience aging, it has to be the brain. From memory, cognition to our emotions and behavior, the nervous system goes through some truly remarkable changes as the years go by. Our next session takes us into the fascinating neurology of aging. Dr. Nirmal Kumar sir draws inspiration from the idea explored in the movie The Curious Case of Benjamin Button, which is a story that imagines what would happen if aging were to happen in reverse. While it's not possible in real life, but it still makes us pause and think about how our brains evolve, adapt, and change through the journey of life. We are all looking forward to your talk, sir. To introduce the chairperson for the session, I now call upon Dr. Rubin. Over to you.
A very good afternoon to one and all for joining us today at this amazing session. It's my privilege to welcome the chairperson of this session, Dr. Sumant Kumar sir, Head of the Department of Biochemistry, Meenakshi Medical College Hospital and Research Institute. Sir has completed his MBBS from Kurnool Medical College and MD from Sri Venkateswara Medical College. Sir has an overall experience of more than 10 years in various reputed medical colleges. Sir has authored more than 15 publications in national and international indexed journals. Sir has undergone various training programs like QMS and internal audit in medical laboratories as per ISO 15189 2012 and also completed BCBR and ACME. Sir has received International Best Researcher Award from ISSN International Science and Technology Awards Congress 2025 on March for the research and excellence in liver disease and vitamin D. On behalf of the entire Biochemistry department, I extend my warmest welcome to you, sir. Over to you, sir. Thank you.
Good afternoon, everyone. Before I introduce my speaker, let me extend my heartfelt thanks to the entire Department of Biochemistry in Saveetha Medical College, especially Dr. Anandi ma'am, Dr. Pawan, who is my friend since my post-graduation days, and Mervin ma'am, main person, Kedari ma'am, Surya Priya ma'am, and all the members of the team of Biochemistry. Thanks a lot for inviting me for this conference. Now, let me take the privilege to introduce our speaker, Dr. Nirmal Kumar sir, who is a dedicated medical professional committed to providing the comprehensive evidence-based patient care while upholding the highest standards of medical ethics. He has completed MBBS in Chengalpattu Medical College. Later, he worked as medical officer in Isbal Hospital, Chennai. And later, he completed general medicine, post-graduation in Madras Medical College. Later, he worked as senior resident in general medicine at Gindi COVID Hospital. By 2024, he completed his DM Neurology in Madras Medical College. And at present, sir is working as assistant professor in the Department of Neurology in Saveetha Medical College. To his credit, he has got 6 publications in national and international journals. He has got a list of chapters written like Stroke, South Asian Perspective, and Persistent Dizziness Monogram on Vertigo. So there are a list of chapters. And regarding the books, he is co-author for the Handbook of Neurological Drugs. And he has been actively participating and have won prizes in quiz competitions. And if I want to quote some of them, at least some of them, like first place in TANCON quiz and Kerala Association of Neurology quiz, second prize in Hematology quiz, third place in national level Torrent Young Scholar and the Shine Quiz Neurology. He has been organizing and teaching in online masterclass on topics like neuroemergency and neuro-opid management, neuroradiology and neuroelectrophysiology, and each of that things will be attended by almost more than 500 attendees. He is the principal creator of DM Neurology, app for NEET at ADR Plexus, and also teaching faculty. He is a core committee member in MMC protocol book. He has got a strong social media presence dedicated to teaching and awareness about the neurology and neuroscience with over 2 lakh followers. and he have given talks in various national and international conferences. Right now he is giving his talk in this international conferences organized by the Saveetha Medical College. So I take the privilege and honor to invite you, and we are very much eagerly, especially myself, eagerly waiting for your talk, sir. Thank you so much. Thanks.
Good afternoon, everyone. Thank you for the invite and thank you for the introduction. And I extend my greetings to Department of Biochemistry, Saveetha Medical College, Anandi Madam, Pavan Sir, Hemalata Madam, Kedari Madam for having me over. I think this is the last session of the whole conference. So I think everything that has to be spoken about aging has been spoken about for the past 2 days. So most of what is going to be spoken in session is going to be a concise version of what has been told over the past 2 days. And I'm happy about the people who have come back. So many people have come back after lunch, and I think I can see a lot of people are attending online also post-lunch last session. I'm very happy about that. So without further ado, we'll start the session. So how many of you have seen this movie, Curious Case of Benjamin Button? So I think 4 or 5 hands are going up, and I think it's a very emotional movie. I personally like that movie a lot. I watched it on Prime like during the COVID period. Now I want to watch it. You have to pay 114 rupees for it. It's only rental now. So as Prime does often, it makes the movies rental. I have to buy it. And as a middle class mentality, we won't rent that movie and watch. So I haven't moved it. Ma'am? Oh, okay. So those of you who watch that movie, it is a movie based, it's a fantasy movie basically, where a person reverses in age. Except for the concept, everything is very real there, and it's very, personally, very emotional movie for me. To the story of the movie, I'll come back to later in the slides. So before that, this is going to be the agenda of the session, molecular basis for aging. I think that has been extensively discussed over the past couple of days, so I'm not going to go into depths of that. How does a normal brain age? How does a normal brain age as opposed to a pathological brain? How does a normal brain age? And what is the influence of sex, that gender on aging? And a short discussion on aging and neurodegeneration, and determinants of what determines how the brain ages, and a few emerging concepts and how to prevent aging and be a Benjamin Button. That's what we're going to discuss through the session. So So as you can see here, by 2040, the percentage of people above 65 and above will almost be twice the number of child less than 5 years of age. So that is going to be the prevalence of elderly people in just about 14 years or 10 years time. So the burden of aging is going to be so much. So this conference is so relevant in that context. I mean, I don't think anybody has a conference on aging before, but this is very relevant to the what is going to happen in the next 10 years. So generally, longevity of any species, first we'll see about how aging occurs or how lifespan is determined in a few species before coming to humans. Generally, longevity is directly proportional or rather inversely proportional to reproductive capacity. So, for example, animals which reproduce avidly don't live so much long. They die immediately after reproduction or after completing their cycle. So it's as if the only goal of animals' life is procreation. That is not far away from humans actually. The ultimate goal of humans is also procreation, except that we don't leave anything behind. We can leave behind memories, but do we have any memories of our ancestors who lived beyond 100 years? We don't actually. So we don't leave behind anything except our progenies. Maybe other thing we leave behind, maybe a legacy. So if suppose we achieve something great in life, we may leave behind a legacy, but I think ultimate goal of human life is also procreation. So by that means, we don't differ much from animals, but general rule is that the reproductive capacity is inversely proportional to age. So animals generally live shorter, humans live longer because of this effect. And evolutionarily, the germ cells, the reproductive cells have preference over somatic cells. So the ultimate, again, the goal of life is to preservation of genes. That's been the ultimate goal. Somatic cells have always been compromised. So aging, accelerated aging occurred after reproduction. That's what usually is the case with animals and also with humans. So this is a very interesting case. This animal is a marsupial rat. Marsupial rat. So this is one animal which undergoes suicide actually. So what happens is that once it reaches a particular age, the testis of the rat undergoes atrophy. So testis produces sperms. So if the testis is not functioning, the only source of the sperms is what is stored in the epididymis. So epididymis is a store of sperms that can store up to like 30-40 days in humans, and I don't think how long it can store in rats. And it constantly gets passed in urine also. The sperm gets passed in urine also because that's directly connected to the urinary tract. So that like a time bomb. So once the testis undergoes atrophy, it has to reproduce in the next 30 days or else it dies. So it is in the race against time to reproduce. As soon as it reproduces or gives its genes off to the female, it dies off. So that is the life of the marsupial rat. Why I am taking this is relevant? Because it undergoes a programmed cell death. So that's aging wise, the only goal is again reproduction for this particular species called as marsupial rats. And again, this animal is a form of a fish. What it does is, it's a salmon actually, salmon fish. So this has a proper biological clock. So this actually is initially born in fresh waters, from where it migrates to sea waters, then the ocean. So it lives its life there, and when it's a term for it to reproduce, it comes back to the fresh water, gives birth, dies there. So it's as if the biological clocks functions around reproduction. So all this I'm saying to say how different we are from these animals and how we evolved aging wise. And this is the longest living mammal. This is the Greenland shark. This lives about 400 years. So now coming to humans, humans generally live for about 60 years on average. Now it's higher. Few populations live up to 85 years, which we'll see later. Average age is 60 years, and that is mainly enhanced by an effect called as grandmother effect. So what is grandmother effect? So grandmother takes care of their grandchildren. By doing so, it allows a mother to produce more progenies. Because they are relieved with the burden of taking care of the child, so they are free to reproduce more progenies, and by that the life of the mother enhances. So they are able to produce more progenies, and this effect keeps running through generations, and that causes reproduction. The main source of reproduction in humans is grandmother effect actually. So without grandmothers, we would all stop with one child, and it doesn't go beyond that. And molecular, I'm not going to depths of it because already been dealt with in the 4 days. Just a few techniques with respect to neurology. So primary hallmarks are genomic instability, epigenetic changes, telomere attrition, and loss of proteostasis. And this causes senescence and metabolic dysregulation. And this causes altered immune system regulation and stem cell exhaustion. And finally, it causes a aged brain. So coming to DNA repair. So DNA constantly undergoes damage. Throughout the life, it constantly undergoes damage. It also undergoes repair. So these two occur simultaneously actually. But as we age, the reparative capacity goes down. The DNA is not able to repair the damaged DNA anymore. And this is more so in case of mitochondrial DNA because a lot of metabolic load is handled by the mitochondria. So mitochondrial DNA has the largest load of the absent DNA repair, and that causes mitochondrial DNA to be affected first. And I hope you know who is this. This is Rachasan Christopher. And what disease he suffered from? He suffered from a disease called as progeria, which means it's basically early aging, and that is a Hindi movie called Pa, and that is, I think you can spot Abhishek Bachchan there, and that is actually Amitabh Bachchan. Amitabh Bachchan played Abhishek Bachchan's son suffering from progeria, and this released in 2009. It's a very nice movie actually, the only movie where Abhishek Bachchan actually acts, but yeah. So progeria is basically mutations in laminin gene, and these mutations cause repair damage and basically accelerated aging takes place. So by 20s, they have atherosclerosis, cataracts and everything. So die off by 30s. That's what happens in the movie. It's a very nice movie. The Pa movie is a very nice movie actually. So again, epigenetic changes is actually a biological clock which says when our time's up. I told you in case of that salmon which undergoes a biological clock surrounding a reproduction. In humans also, there is a DNA. As you can see, there is a DNA. sorry. Oh, okay, okay. No problem. இல்லை சேஞ்ச் இல்லை பாயிண்டர் இல்லையா சரி நோ ப்ராப்ளம் இதை காமிச்சிக்கலாம் ஸோ ஆஸ் யூ கேன் சி ஹியர் இஸ் த டிஎன்ஏ வர மாட்டேங்கிறாங்க சரி நோ ப்ராப்ளம் ஸோ there is a DNA in the center which is surrounded by histone. So DNA is, as we know, is a gene of the humans, and histone is not the gene, it's non-coding, but it binds with the DNA. So when it binds with the DNA, it can influence the DNA expression, and if DNA is methylated or deacylated, the DNA expression decreases. This is to say that the number of cells having the methylated DNA or deacylated DNA increases as the humans age. So we don't know if this causes aging or aging causes this. It's like cause effect. We don't know which came first, like in the case of egg and hen. We don't know which came first, but this is a molecular signature of aging. And telomere shortening, we know that. I'm not going to repeat that. Telomere gets shortened as we age, and finally it undergoes senescence. It doesn't multiply anymore. It enters senescence. It doesn't multiply. And this is telomere shortening. This occurs throughout our life. And finally, loss of proteostasis. This is very important neurologically because loss of proteostasis causes protein misfolding, and protein misfolding is very relevant in case of two diseases actually. I mean many diseases, but two main pathologies. That's amyloid pathway. Amyloidogenic pathway, that means amyloid which has to be cleared has to undergo cut by alpha secretase. That means it won't accumulate, but it's cut by beta secretase. It can accumulate because that amyloidogenic pathway doesn't metabolize the remaining amyloid, and that accumulates as amyloid protein, and that causes, you can see the amyloid plaques there, that causes Alzheimer's disease, and that is a gross specimen of patients with Alzheimer's disease. And the other disease where protein aggregation occurs is Parkinson disease and its spectrum of diseases. This is an alpha-synuclein which is accumulated intracellularly, and the spectrum which comes under alpha-synucleinopathies is Parkinson disease, dementia with Lewy bodies, and multisystem atrophy. All these are neurodegenerative diseases. And I think this was also discussed previously. There are few nutrient pathways implicated in aging. The IGF-1 pathway, insulin growth factor pathway. The more the IGF pathway, the more we age. mTOR pathway, which is mammalian target of rapamycin. Higher the pathway, higher we age. SIR-twins, which are actually anti-aging properties, and AMP kinase also has anti-aging properties. And these can be targeted actually by few drugs. So by doing caloric restriction, we can control this pathway. As I told you, this mammalian target of rapamycin binds to that pathway. SIR-twins are present in resveratrol, which is present in red wine. That's why red wine has always been told that's an anti-aging property. And metformin has anti-aging properties. All these are anti-aging and antioxidant properties. And there are few hallmark diseases of aging, as we discussed previously in the previous sessions also. It's osteoporosis, sarcopenia, heart disease, cataract, dementia. I think there's a session on each of these syndromes. I'm not going to go in depth of that. So now coming to what happens to brain during aging. So there is, by all this process I mentioned above, there is a mitochondrial damage, and that causes energy failure because mitochondria is the power of the cell. So that causes energy deficit, and there is more of connection deficit than actual volume loss. That means the synaptic connections are lost, and that causes aging. And there is cortical age, which is directly proportional to grip strength and neutrophil lymphocyte ratio. So this is what we can practically see. If you have your grandparents or parents who are aging, just check the grip strength. If grip strength is low, that directly corresponds to the brain age. And neutrophil lymphocyte ratio means neutrophil is higher than lymphocytes, much higher than lymphocytes, more than ratio of 3:1. If that is there, that means there is chronic systemic inflammation which can accelerate the brain aging. So there are few determinants of brain aging. Socioeconomic status, that means poorer we are as adults, then more we age. Systemic inflammation, which we discussed now. Metabolic derangements like insulin resistance, dyslipidemia can accelerate aging. And finally, sex. Means males age faster than women. Males' biological age and actual age actually is much higher than women. So this can be attributed to hormonal factors as well as X chromosome, because female has an extra X chromosome which has anti-aging genes, and one such gene is KDM6A, which is an extra anti-aging gene. So how does it reflect cognitively? So if you see patients with age, you might have noticed all this innately. That means they have a lot of functional disconnections rather than structural problems, and cognitive decline occurs 5% every decade after 40 years of age. So what happens actually? The frontal lobe and the temporal lobes are most affected. So in frontal lobe dysfunction, there is decreased processing speed. So they answer questions much slower than the normal people, or much slower than the younger people. And there is decreased fluid memory. So what is fluid memory? There are two types of intelligence actually. This can be broadly classified as two types of intelligence. One is a crystallized intelligence, the other is fluid intelligence. So you would have noticed your professors or your senior people, senior consultants, seeing a patient, coming to diagnose within seconds. So how do they do it? That is because it's basically pattern recognition. They have seen diseases before. For example, confined to neurology, we see a stroke patient. I might be able to diagnose it in maybe 2 minutes. Satish sir may be able to diagnose it in 1 minute. And HOD maybe even diagnose it on a phone call, or even without seeing, by just hearing what is the patient is saying. That occurs because of heuristics. Heuristics means probable guess, the most educated guess. That occurs because of heuristics. And that is better with age. So that is always better with age. That is what we call it experience. The term experience actually means this, the crystallized intelligence. But fluid intelligence. So say an elderly patient encounters a case which they want to write a case report on. They will be much slower to do it than a younger person who has knowledge of artificial intelligence. So they will do it much faster. That is because they will have fluid intelligence. They will have interest to learn more things. Whereas elderly people will be more fixated. They will do things only their way. So they have a way of doing things. They will only stick to that way. They won't be flexible to ideas. That flexibility occurs in younger age. So this is normal aging. This is a continuous process, not a difference. It's a continuous process. This is what I told you now. So not only the gray matter undergoes aging, the white matter undergoes long-term change. So you can see that the white things on the MRI, if you had seen the MRI or read the report, they were reported as small vessel change. These get accumulating with age. And so not only the gray matter undergoes aging, the white matter also undergoes aging. It has a lot of vascular burden. It burns a lot of vascular burden over the years. And this causes actually decreased reflex time. They answer much slower because of this actually. So we talked about the structural change, the functional change. The neurochemical change also occurs. There is decreased dopamine, there is decreased serotonin, and there is this acetylcholine. So acetylcholine, there is cognitive deficit, higher dementia risk. Serotonin interferes with sleep, there is a lot of mood changes. And dopamine we know is a happy hormone. There is lack of pleasure, lack of motivation, and dopamine is deficient. So I'm sure your grandparents who have all these problems, they will have frequent arousals, they will have a fragmented sleep, they won't have a sound sleep because they never enter the deeper stages of sleep, because that is how evolution occurs with age. The serotonin goes down in the brain and norepinephrine goes down, the cholinergic neurons go down. All this causes sleep disturbance. And how does it reflect? It reflects in sleep fragmentation, decrease deeper stage of, they never go to deep stage of sleep. They will always be in the stage N1, N2 of sleep, and it causes early sleep-wake cycle disorder. You will notice them sleeping at 8 a.m. and 8 p.m. waking up at 4 a.m., right? And that is also occurs with aging. So what does the brain do to compensate for this? It compensates by recruiting more areas compared to healthy brains. For example, if I use only the right hemisphere for visual memory, elderly patient's brain will use both hemispheres. So it compensates by recruiting more areas, and this is called as hemispheric asymmetry reduction in older adults. It's called HARALD. That means basically there is no asymmetry when one area's brain is recruited, both areas are recruited on both sides. So what is normal aging? What is dementia? So this is important difference to know, because forgetfulness is normal part of elderly. So when do we categorize them as dementia and start actual treatment? But you have to remember it's a continuum. It's a small thin line through which this occurs. It's a continuum. So this can progress to that. It's always a continuous process, but generally slower recall is normal aging. Word finding difficulty is normal aging. Misplacing objects is normal aging. Also independent living, but they'll be able to carry out their own work. They'll be able to live without any other's help. But early dementia, they will have impaired recall. That means if you say an object, ask them to recall, they might have forgotten that you gave them an object itself. So to that extent there will be dementia, that is early dementia. There can be breakdown of language. They may lose objects, not only misplacing, they may frequently lose objects, and they might need assistance for daily ambulation. And these are new emerging concept, neuroinflammation, G lymphatic system, and the gut-brain axis. So as we age, there is shift of microglial cells, which is the inflammatory cells in the CNS, towards inflammation, and this causes chronic inflammation, and this causes oxidative damage, and finally there is neurodegenerative diseases. This is a pathway for neurodegenerative diseases which occurs through aging, and some people fall into the category of disease, some people don't. That's the major difference. Next is G lymphatic system. So we have traditionally been taught that the brain doesn't have lymphatics. Well, it doesn't, but it does have something called as G lymphatics. You can see this end where there is arterial end, there is CSF leakage from this end, and that communicates to venous end. So there is a trans-arteriovenous communication. This is the G lymphatic system. The main purpose of the system is to clear the waste. So this functions the most in sleep, and it clears the waste of the brain. So all the toxins that accumulate throughout the day is cleared by this system. So when you don't sleep properly, this system goes in for hyperfunction and the waste gets accumulated. This is how Alzheimer's disease develops. So sleep is very important. Sleep is extremely important for neurological aging and neurological health. And finally, as a gut-brain axis, I'm pretty sure they would have been spoken about in the gastro session. As simple points about that, gut-brain dysbiosis has been implicated in neurodegenerative disease like Alzheimer's disease and Parkinson's disease. It causes blood-brain barrier breakdown, causing chronic inflammation, and that chronic inflammation can indeed cause aging, which we discussed here. And finally, good gut bacteria produce something called as short chain fatty acids, which can augment gut and brain health. So recently this was published in Lancet. You might have noticed that you would have seen someone like 1 year back. You wouldn't have found them to be old, but suddenly now we find them to be old, because it has been found that aging occurs not linearly, it occurs as bundles, meaning it occurs in two bundles, one at 40 years of age, one at 60 years of age. So 35, 36, 37, the age accumulates but doesn't show on the face or show on the activities. But once it touches 40, it again becomes very prominent. 40 to 60 is one bundle, there will be again, you won't find them age much. Above 60, they again age rapidly. And this is because of metabolic shifts in glucose metabolism, lipids, and all the metabolism shifts occurs in bundles. That's what this study showed. And what can be done to modify your brain aging? So we saw how we age and a lot of things we saw, but how do we actually modify brain aging? So the best evidence of all the things I think which was discussed in the last session also is exercise. So the best evidence is for exercise, not for medicines, not for anything else, it's for exercise. So what is the actual advised exercise levels? So strength exercise training, which aerobic exercise 150 minutes per week, more than 2 days of strength training at least per week, and daily mobility. So these three are the only proven intervention to improve brain aging or reverse brain aging. And this is the Mediterranean diet. Recently it was modified also. Before it used to be a lot of carbs, lesser proteins, but now it has been modified to more proteins, lesser carbs. On the whole, you should eat whole foods and mainly from fruit-based diet, vegetable-based diet, and occasional intake of red meats. That's what Mediterranean diet says so. And there is something called as Okinawa diet. Okinawa diet has the world's most average lifespan. 87 years for women and 80 years for men. That's average. They usually touch 129, 130 years easily actually. So their diet is actually based upon plant-based diet. It's a phyto-based diet with little bit of fish and little bit of pork, and it's mainly antioxidant rich and also rich in phyto, plant-based diet. That's what Okinawa diet is. You can Google it up, you will know what is Okinawa diet. And you know why women live longer than men? Because of activities like this, and that is why their average also was higher for women than men. So there are some other measures to avoid aging. Air pollution is very important. There's a particle called as P250, which is P2.5, which is very important and causes accelerated brain aging. And Delhi people can age much faster than us because of all this. And BP control, because I told you that as we age, there's a larger small vessel disease burden, and blood pressure control reverses that. And finally, hearing aids, that is very important. People with lack of hearing, once you don't put them on hearing aids, they will age much more. They will have disconnectivity. So they disconnect from the entire world, their age becomes much more prominent. So again, one more thing which has been proven to have an effect is intermittent fasting. And this is Ramzan season. I think Muslims have been fasting now, but this is there in all the religions. And this is the reason why, because it delays aging. So 48 hours fast once or twice a month is advised, or alternate day fasting, or 5:2. That means you eat 5 times a week, you don't eat 2 times a week. That's what is 5:2 fasting. So again, we discussed about the drugs, but none of these are proven to have anti-aging properties. All these have relatively good antioxidant properties, but none of these are 100% proven to have anti-aging properties. So this is an excerpt from Benjamin Button. For what it's worth, it's never too late to be whoever you want to be, and our lives are defined by opportunities, even the ones we miss. So what happens in Benjamin Button, if for those who haven't seen the movie, is that he is actually born in a for biological parents who obviously, seeing his looks, throw him away. He is brought up by a shelter home. Then he grows up with elderly people there because he looks like 8 years at birth. He grows up with elderly people there. Then as he ages, he moves away. His biological parents die off. His caretaker dies off. He meets his love of his life, Daisy. But the problem is, at the time he looks like a 60-year-old. That girl looks like 20 years old. So they actually can't get into a relationship for some reason. Then their life goes on. They meet again. This guy is 40, that girl is 40. Because they're aging in reverse, right? This girl is aging linearly and that guy is coming from there. So they meet at 40 years of age. They have a kid. And that kid, actually, he can't take care of the kid because he is going in reverse. He is going to become baby soon. So he is going in reverse, right? So he gives up the kid to the mother. He again goes on an adventure. He comes back as a teenage. He is got up in some drunkard case. He comes back as a teenage guy. Then he takes him in. The girl takes that guy in. And finally, that guy dies in her own lap as a 1-year-old baby. And with extensive dementia, even though his physical age is 1 year, all the organs are 80 years old, he dies in the lap of his lover as a 1-year-old infant. And that's a very emotional part for me because the whole life is shown to you and you know how aging takes a toll on you. So this quote says that it's never too late to reverse all you want, reverse the age, and all you got to do is these 3 things. Eat right, move around and have sound sleep, and I think we'll conquer age soon. Thank you.
Thank you so much, sir. That was one amazing session. Your talk beautifully highlighted the neurological dimensions of aging, reminding us how complex and remarkable the human brain truly is. And hey, ma'am, please send me the link of that movie, even if all of us will watch together one day. And the floor is open for discussion. Any questions? You can shoot it now.
So can I ask one doubt, sir?
Sure, sir.
Regarding the sleep disturbances you said, because when there is aging, you said there is derangement. Of course, whenever we have a discussion about this one, most of the people, they will be saying, you do meditation, you start doing yoga, or you should reduce your screen time, all these things. Because I am having a neurologist in front of me, I want to have a clear-cut idea what has to be done to overcome this problem of sleeping, to have a sound sleep.
There is something called a sleep hygiene, sir. It is actually written in Harrison. It's the sleep hygiene. That means you got to get rid of your screens by 2 hours before sleep. No coffees after 3 p.m. You use only bed for 2 things, sleep and sex. And you eat a healthy diet. And again, no alcohol or smoking before bedtime. 2 hours before bedtime, no alcohol, no smoking. And diet, last meal should be at least 2-3 hours before bedtime. This is called a sleep hygiene, where you maintain a healthy relationship with sleep. And of course, you work in the day, you do all this. I generally think the sleep will be good, sir. But we don't do all this, that is a problem.
That is the problem. But for a doctor, even in the night times also we'll be getting phone calls and messages and we have to attend definitely.
Correct.
So for these people, what has to be done?
Each one has their own setup of sleep, sir. In the sense, I don't have, even though I get calls, I don't have a problem with sleeping back, but some people do have a problem, but I think that's about their own lifestyle. They have to do some things, tweak some things to overcome that, sir.
Thank you, sir. Thank you.
Any more questions?
And any more questions from the... Yeah, let me... So I had a very nice topic today. I have listened to from Dr. Nirmal sir. So it was a nice presentation, sir, really, because I was totally immersed in, like as if I thought I was watching that movie. I don't know that movie also, but I felt like that I am watching the movie. So that's a nice presentation. And of course, many of the things are like pointing to me or to our people, our relatives and parents. But most of the things we are unable to overcome because of our hectic life. So thank you very much for this one. And any questions from the audience?
Hi sir, it was a nice session, sir. I have one question which I was curious about. So as we are speaking about the brain aging which is related to dementia, Parkinson's and Alzheimer's, I just want to know whether you are come across the patients with the schizophrenia with this brain aging thing. Is there any cases which you had seen, sir? Because in one slide you had shown like mild, moderate and severe, the white matter on the which is related to the aging also. So whether is there any linkage with the schizophrenia?
Schizophrenia is not generally a disease of aging, ma'am.
It's not related to aging, but it is related to, I mean, it's as it is related to if there is any brain linkages with these conditions. I'm just very curious of that.
It doesn't lead to usually schizophrenia, ma'am, but it does lead to vascular dementia. We saw all the small vessel changes that can lead to vascular dementia. A lot of small vessel burden load, the connectivity decreases between the cortex and the lower structures. And that leads to vascular dementia. That's very common with this, all this.
Nowadays, it's most of the cases like based on this aging people, like we have this conditions like either it is in the moderate, most of the people having this severe state of these things. So whether in the patient's categorization, so I just thought like when it is in Parkinson's, when we face this type of conditions, and also in Alzheimer's when we can see these type of gray matter changes in the brain. So I was thinking like whether is there any changes in the schizophrenic also. So I'm just if we observe that, maybe we can know that. Thank you so much, sir. Thank you.
Sir, everyone asked me when you gave this title to us, sir. I put it at as my WhatsApp status, and I encourage many to watch this movie, even including my madam. I propagated, for past 1 month I was canvassing about this movie. One thing is, many asked me whether this is reverse aging, that is reverse progeria, is just a science fiction or a real case?
It's a fiction only, ma'am.
Fiction only. Because I have Googled it, I haven't seen any evidence-based thing. That's why I'm asking you.
It's a fiction only, ma'am, but very nice fiction actually.
I can understand that, sir. The way you explained the movie.
Maybe you are planning for that one. If it is real means you want to plan for that one. Reverse aging.
With that said, I would like to call upon Guru Pavan sir and Satish sir to felicitate both the speaker and the moderator of the session. Refreshments have been arranged outside the hall. So we'll break for tea and then we'll reconvene here in another 10 to 15 minutes. I repeat, refreshments have been arranged right outside the hall. So have a break and come back again in 10 minutes. We'll have our most awaited prize distribution. So let's see who won the conference's competitions. So to the science of aging, exploring it from many angles like molecular biology, metabolism, nutrition, cardiology, cosmetology, and even neurology. Each session has helped us peel back another layer of this fascinating and a very complex process we call aging. And of course, what's a conference without a little celebration? So now the moment has arrived for which you all been eagerly waiting for since the day one, the prize distribution ceremony. To announce the winners, I would like to invite Pavan sir to the stage. And everyone, please be ready to clap your hands loud for the stars of the day. Over to you, sir.
Thank you, Amara. So the winners for poster presentation faculty category will be, first prize goes to Dr. Veena of Panimal Medical College and Dr. Bashira of Clinical Hospitals. Second prize goes to Dr. S. Aishwarya of Panimal Medical College along with Setupati A of MGR Educational Institution and Research Campus. Whereas under the research scholar category for the poster presentation, it is Silambarsan K from Saveetha Medical College and S. Punguri from Center Research Laboratory of Meenakshi Medical College Hospital. And the third prize goes to Neha Brahma of Saveetha Medical College. Whereas under the postgraduate category in medical, it is Dr. Abhinav Shukla of ESI Medical College, Faridabad, and Dr. Akriti Gupta of Maulana Azad Medical College, Delhi. Whereas under postgraduates in allied category, it is Lakshmi Gayatri from Satyabama University and Meenakshi Sundaram from Meenakshi College of Physiotherapy. Whereas for the poster winners under UG medical category, it is Bhumi Kalamane from Shimoga Institute, Shimoga. And under dental category, we have Ananya from Army College of Dental Sciences, Pragya as well from Army College of Dental Sciences, Zoha Khan from Pania Institute of Dental Sciences. Whereas undergraduate allied category, Afroz from BS Abdul Rahman Crescent Institute and Meena from Saveetha College of Physiotherapy. I think one of them is there, Silambarsan K. Whereas for oral presentation, under faculty category, it is Dr. Netravati Sajjan from Navodaya Medical College, Raichur, and Dr. Sara Benny from Ramaya Medical College, Bangalore. Both have got the first place. Whereas Dr. Devaki RN from Chamraj Institute of Medical Sciences and Dr. Sai Deepika from Sri Devaraj URS Medical College has got the second prize. Whereas under the research scholar category, the first prize goes to Elsalvat Sukanya from Meenakshi Academy of Higher Education and Research and Balaji MB from Saveetha Medical College. The second prize goes to Supriya Pandey from NIMS University, Rajasthan, along with B. Swati Pandey from Sri Ramchandra Institute of Higher Education. Whereas under postgraduate category, the first prize goes to Dr. Spurti S. from Pandit B.D. Sharma PGMS Institute, Rohtak, Vishnuvat from Chetnad Hospital, and Adria Salim from University of Indonesia, along with Lakshmi Gayatri from Satyabama University, Devapriya Kaviyarsan from Saveetha Medical College. Whereas the second prize goes to Mohammad Sakin from Mahatma Gandhi College and Research Institute, Dr. Ovia from Saveetha Medical College, Dr. Ojas Kumar from Jawaharlal Nehru Medical College, Belgaum, Dr. Charanya from Government Mohan Kumar Mangalam Medical College, Salem, Dr. Saujanya from Gulbarga Institute, along with Angel from Saveetha Medical College. Whereas for oral presentation under undergraduate category, We have Fatima Roshmi from BS Abdul Rahman Crescent Institute, Afroz Mariam from BS Abdul Rahman Crescent Institute, along with Pragya from Army College of Dental Sciences and Amrita from BS Abdul Rahman Crescent Institute. Under UG category, we have Meena over here. Balaji MB. And we did have memes and reels competition as well as a part of the social media outreach. So the first prize for memes went to Tamanna Bharatwal from Army College of Dental Sciences and Nishant M from Saveetha Medical College. Whereas second prize goes to Kota Niranjan from Government Medical College Sangareddy along with Karthik from Saveetha Medical College. Whereas third prize Puvarasan from Saveetha Medical College and John Kennedy Preeti from Saveetha Medical College. Whereas the most popular contest we had, so the most popular meme went to Mr. Sri Harish S from Saveetha Medical College and A. Balaji from Saveetha Medical College. Whereas the reels winner, the first prize Naram Veer Raghavulu from Saveetha Medical College, second prize Jashwita Nandyala from CMATS, whereas third prize to Tamanna Bharatwal from Army College of Dental Sciences.
Nishant? Jugunta Karthik from Saveetha Medical College. Puvarasan from Saveetha Medical College. John Kennedy Preeti from Saveetha Medical College. It's not there. Naram Veera Ragavalu from Saveetha Medical College. Jashwita Nandyala from CMATS. Okay. Sri Harish from Saveetha Medical College. Akrambeti Balaji from Saveetha Medical College. Congrats to all the winners. And just like that, we've arrived at the end of what has been a truly remarkable and a wonderful conference. Before we wrap up, I would like to take a moment to thank everyone who made this event possible. From? Sai Deepika. Penna.
Second prize in oral presentation.
Sai Deepika has secured second prize in oral presentation. That's it? Okay. Congrats to all the winners again. And just like that, we've arrived at the end of a remarkable and a wonderful conference. Before we wrap up, I would like to take a moment to thank everyone who made this event possible. To our esteemed speakers, the true captains who steered this conference towards success, And a very big round of appreciation also goes to the organizing team and everyone working behind the scenes. From planning to execution, your dedication, patience, and countless hours of hard work truly brought this conference to life. Over the past 2 days, we didn't just attend sessions. We exchanged ideas, sparked curiosity, and explored the fascinating science of aging together. And hopefully, we all leave today with a little more knowledge, a little more inspiration, and a way more new ideas to think about. I truly hope this conference was as enriching and enjoyable for all of you as it was for us organizing it. This is Amara Farhin signing off, and thank you everyone. Have a wonderful day ahead. I would like to invite all the participants in the hall to the stage so that we can have a group photo. I repeat, please come to the dais so that we can have a group photo to capture the moment